Very good afternoon, dear students. Welcome to the live virtual classes organized by the Board of Studies Academic ICAI. In our session today, we are taking up the topic of chapter 16, that is theoretical distributions. So at the very outset, please note that in the last session, we had detailed discussions and explanations of probability, including the concept of random variable and the fact that random variable can be both discrete and continuous. So based on that initial discussion, we will take it forward in today's session. I also request Ravi sir, good afternoon, sir. Very good afternoon, sir.
Good afternoon, sir. Welcome to the live virtual classes.
Thank you, sir.
Once again to you. And last session, I was also in your debate and discussion. It was one of the good lectures I had been noticed from the live virtual classes, and it's my pleasure. And the students are also very much enjoyed with the getting the knowledge, good knowledge, and you have been elaborated and deeply logical related to the probability and their respective outcomes. Total outcomes are also very well defined. And once they have been concentrated very well, the probability of success, the final note was 100%. It is a
Yes, sir. Yes,
very
sir.
good point. Student has to be remember this very important point. Behind entire thing of this section also be the very important also be. Further, we are moving to the next important aspect. This is that was the basic foundation for the understanding of this concept, which is used in the real life also be in the business, economics, and commerce as chartered accountancy students, how it is further used in the real life scenario also be that. Here, the concept is probability distributions. One is discrete, another one is continuous also be. In the though we have the several this kind of functions initially that Bernoullian distribution, binomial distribution, and further Poisson distribution are also be there as a part of these are all comes under the discrete distributions are also be there. And next is the continuous distributions. There are several continuous distributions are also. We are limiting in the case of only the normal distribution only in the foundation level only. As for the syllabus is concerned also be. And when we talk about the binomial, y means here two only. Probability of success or failure. The outcome is the probability of the getting this is the same actually constant than only the success or failure actually be. But in case of that, yes, probability of success or failure, yes or no, or like that, the probability of passing a student is a pass or fail. Yes, that pass or fail, and profit or loss, like that two cases actually only. When we talking about the only what is the profit case actually, what is the loss case also, and a default or when the loan is getting the for default or no default also be. This is the one case. And here the case is like a binomial is a fixed number of trials also be there. What is trials also be there? Two outcomes we are concerned about that the probability remains constant there actually. That is about this. The trials are here independent also be that. This is a business examples just I had been thrown to also to understand further future foundation for the chartered accountancy students are also. And the next one is we are talking about the Poisson distribution also. The Poisson distribution is the case like it is occurred in a rarely happening. That suppose in a standard study material also be the errors occur in a place also be very rare. Even if we take it in a same simple auditing as a one standard furnace also be coming to the error also be noticed also be very rarely be. In that case also be we use the standard Poisson distributions or also be Poisson models of it. Here where in that Poisson distribution mean and variance are equal also be that. that is a special case. And what is the mean of the binomial distribution? What is the variance of the binomial distribution? All these things are very, very important. Further, the normal distribution also be very, very important. It is in the bell-shaped curve, and we have to discuss about the deeply and their properties. What is the standard deviation and mean deviation? So from the various aspects also be that. Uh, this is the background I want to say. And Sir is here. Sir is a very well noted teacher in this, and he is a um, especially he is a master's in the explaining the especially business and commerce examples also. Even I love to hear that kind of examples from his lectures also. Above all, from these chapters, we can expect that 5 to 6 questions are expecting from this chapter. And this is a very, very important and interesting chapter also. Above all, are all formula predetermined cases only. We don't want give any kind of this. So you have to find as a student of chartered accountancy foundation student, what is the mean of the binomial distribution? What is the variance of the binomial distribution? What is the standard deviation of the binomial? Similar way, in the case of Poisson distribution, what is the mean and variance and like that, and whatever the expectations are there. This is as basic foundations only from here. Examination is also be tested based on this kind of, and even in the normal distribution, the shape of the normal distribution, bell-shaped curve, and what is the mean, median, and variance are kind of like mean, median, mode are equal when the what is the cases, and above all mean deviation, standard deviation, and all kind of factors would be tested also with it. Over to Chakraborty sir. Welcome you once again
Thank
for
you, sir.
delivering.
Thank you, sir. Very good afternoon, and thank you for your comprehensive explanation of each of the distributions we are going to go through. So thanks a lot, sir. And with that, we will first look into, as sir gave us the beautiful flow of the entire discussion we are going to have. So first, we will start quickly with a quick recap of the concept of random variable, and then we will move into the understanding of probability distribution. So in our last session on probability, we had learned that a random variable is basically, it can have any type of it can assume any value on different occasions, and it is not possible to completely predict what will be the value. That is why it is called random. So, for example, the maximum temperature on a day, or say the number of cyclones in a season, whether there is going to be rain or no rain on a specific day, say tomorrow. So it is sometimes very difficult to predict with complete accuracy. So that is the idea of random variable. And as we had earlier discussed, that random variables are of two types. You have initially the first, the easiest one we can think of is the continuous random variable, which can assume any value within a given range. For example, the temperature, pressure, or even the electric voltage, right? When you talk about the weight, so these can assume any value within a defined range. So maybe we can say that the crop yield, or say the pressure, or say the weight. So weight always positive, but weight can also assume fractional values. Similarly, the maximum temperature can be both positive and negative. We can have temperature below 0 degrees, and it can assume fractional values. So these are continuous within a given range. Then we have the discrete variable. So the discrete variable it is going to only assume specific values. For example, the number of cyclones, this cannot be fractional. This cannot be negative. The rain or no rain, so either you have rain or no rain. Similarly, the number of scratches on a surface, or say the number of printing mistakes in a page in a book. So it can never be negative. It cannot be fractional. It will always be a positive value. So therefore, this is the basic idea of what is meant by the random variable. And there are two types: the discrete, which assumes specific values, and the continuous random variable, which can assume any value within a given range. So please remember this important point. And now, how do we get a probability distribution? So when we measure the random variable many times, right? So what happens is we can build up a distribution that, okay, this is the value, how many times this value we are getting. So in number of trials, as sir was mentioning, the Bernoulli trials. So we can get the number of trials, and out of the trials, we can actually measure how many times a random variable is assuming a specific value. And as we increase the number of measurements under the same conditions, we will get a probability distribution for that particular random variable. So this is the link or the connection between random variable and probability distribution. So once we start doing the random experiment, you may remember that we had discussed in detail about what is meant by random experiment. For every random experiment, you have an outcome or a result, which we term as event, right? So as the number of trials increases, we will get a distribution of the possible values which the random variable is assuming. And from the values, we will get to see, ultimately, we can calculate the mean which is seen as a parameter, and also the standard deviation of the values. So now we see that the probability distribution, as sir was mentioning and explaining, that even the binomial probability distribution or the Poisson probability distribution and the normal, they have their own mean, they have standard deviation. And as sir guided all of you, that for the exam perspective, we should be absolutely clear about the parameters which are there for each of the theoretical distributions, as well as we should remember by heart what is the mean, what is the standard deviation. And in case of normal distribution, we have number of properties which we will slowly understand, and periodically during our session today, we will revise multiple times so that we get a complete idea and grip on this particular subject. So probability distribution, as sir again explained and gave a number of examples, it has practical value. Why we are studying in CA this particular chapter is simply because of its application in manufacturing industry, in service sector, in defense, in virtually all branches of commerce, industry, business, economy. So we can see the tremendous practical applications of probability and probability distribution. Now we look at the discrete probability distribution. So for example, the random variable has two values, rain or no rain, and say the probability of rain is 0.2, and therefore the probability of no rain is the complementary event. So the probability of not having rain is equal to 1 minus 0.2. So this is how you get the probability of the rain and the probability of no rain. Here we are given the probability of rain, and we have calculated the probability of not having any rain. With that basic background, if we try to create a probability distribution and let X, capital X, be the number of sunny days in a 10-day period. So here X, capital X, stands for the number of sunny days. So now we can find out from the binomial distribution or other important types of distribution, we can actually find out that out of the 10 days, what is the probability that we will not get even one sunny day. That means the probability of getting 0 sunny days, because X stands for number of sunny days. Similarly, probability that X equal to 1, which means out of 10 days, there will be exactly one sunny day. In this way, probability X equal to 0, probability of X equal to 1, X equal to 2. In this way, we can build up the probability distribution. And the sum of the individual probability will always be equal to 1. So this is the idea of discrete probability distribution, which is the first part of our detailed discussion today. And we see that there are two types of discrete probability distribution. The first is the binomial, and the other one is known as the Poisson distribution. Please note that in the case of these two distributions, we will use a term which is known as PMF, probability mass function, right? Probability mass function. Why? Because since, please note very carefully, dear students, since this is a discrete probability distribution, please note it is possible to find out the exact probability. Say, for example, the probability that x will assume the value x equal to 1 or x equal to 1.5 or x equal to 2. We can exactly measure the probability. So that is why it is called the probability mass function for discrete values. On the other hand, for the continuous probability distributions, you will observe in a little while from now that we will not use the term probability mass function. We shall use the term probability density function. So there is a little difference between these two. Why? In case of discrete probability distribution like binomial or Poisson, we are actually able to find out the exact probability for each value which the variable assumes. Why? Because here the variable x will assume only discrete values, specific values. So it is possible statistically, mathematically, to identify that if x equal to so much, what is the probability of this value? So the probability that x assumes a specific value, we can actually establish that with 100% accuracy. So it is known as the probability mass function. However, in case of continuous probability distribution, please note that the random variable can take up all values. As we saw, temperature can be fractional. Temperature on a day can be negative. So within a defined range, it can assume negative values, positive values, integer, that means whole number, as well as fraction. That means it will assume virtually infinite number of, uncountable number of values. Therefore, since the number of values it can assume in case of a continuous variable we are talking about within a given range, the continuous variable can assume any value. Any means uncountable. So it is not possible to identify the probability for each specific value. So therefore, you can see on the slide I have written that since the continuous variable can take all values within a range, it is not possible to assign probabilities for individual value. But this is possible in case of discrete probability distribution. Why? Because there we have a countably finite, or we can call it rather countably infinite, but we can count it. The number is huge, but we can count it. But in case of normal, we will not be able to count. So in case of continuous probability distribution, we use a term called the probability density function. So in case of discrete, we use the term PMF, probability mass function. But in case of the continuous distribution, like normal distribution, we will use the term probability density function. And as you can see there, we will not be able to find out the probability of x assuming a particular value, right? A point estimate, we will not be able to get. But what we will get is the probability of x assuming a value within any interval. So that is why in case of probability distribution, which is continuous in nature, we will draw the normal curve. We will draw a curve. And from the curve, and with the prior knowledge which all of you have about integral calculus, you may remember in case of integral calculus, it is used to estimate the total area within a curve, of course, given two extreme points, given a range. So that particular knowledge, that principle which you learned in the chapter on integration, integral calculus, and the understanding which we are now developing together, you will be able to understand you'll be able to appreciate that in case of the normal distribution or any continuous distribution, the probability will be calculated as an area under the curve. And the total area under the curve will always be equal to 1, because we know the total probability cannot exceed 1. So this is the idea of what is discrete random variable, continuous random variable, and from there, how we can create the probability mass function, which is used for discrete probability distributions. And we have also discussed how we can calculate the probability density function and what is the difference between the PMF and the PDF. That means the probability mass function and the probability density function. So please remember, for discrete random variable, we have two types of probability distribution, which is part of our curriculum. That is the binomial and the Poisson. So the binomial and the Poisson distributions, these are specific examples of discrete probability distributions. However, for the continuous probability distribution, of course, there are a number of types of distributions which are for continuous variables, but for our curriculum, for our exam purposes, we will learn in details only one type of distribution under the continuous category, that is the normal distribution. So you can see on the slide the three distributions and the probability functions are given. Binomial, you can see, is basically n combination x, p to the power x, q to the power n minus x. So binomial, we will see, is used for fixed number of trials and it is discrete. That means the variable will assume only specific values and it will be finite. So x can assume values from 0, 1, 2, 3 up to n, and these are positive. Poisson, the next distribution, the probability mass function you can see is given by E is the Euler's constant, E to the power minus m multiplied by m to the power x divided by x factorial. So this, as Ravi sir was explaining in the very beginning, that Poisson distribution is used for extremely rare cases, rare events. So how will you understand in the exam which formula to apply, binomial or Poisson? So when you see that the given question in the exam is typically regarding a situation where, say, it's like a coin tossing or throwing a dice, or the problem is regarding rain or no rain, you will be able to understand it is basically a question on binomial distribution. On the other hand, if you see a question which has something like, say, the number of mistakes in a batch of 100 articles, or if it is given something very rare, so the probability of accidents, railway accidents, questions on accidents, questions on number of people entering a room on a particular, say, the number of cars entering, say, for example, a petrol station, a service station on a particular day or a particular time, or if a space interval is given or a time interval is given. For example, number of phone calls which we receive, number of customer complaints which a company receives. These are indications, dear students, that we have to apply the Poisson distribution. And for normal, we will discuss in detail a little later. As you can see, sir mentioned that the normal curve or the normal distribution is shown by a bell-shaped curve, which we will see will be a symmetric curve. Please recall our discussion in chapter 13, the first session on statistics, where we had a deep dive into the types of curves. So you may remember that we were discussing about 4 types of curves. We have the bell-shaped curve, we have the U curve, we have the J curve, and we have the mixed curve. So normal distribution is shown by the bell-shaped curve, right? So please remember these points. Now we will enter into the binomial distribution. On the slide, you can see the photograph of Jacob Bernoulli, the well-known scientist, mathematician, who created the understanding of binomial distribution. So binomial distribution is a discrete probability distribution, and here the trials are independent, and the trials will have only two outcomes, like tossing a coin, like rain or no rain. For example, the gender, male or female. So we have specific number of, we have outcomes, and that is two. So as you can see, for genetic experiments, for coin tossing experiments, normally we will be using the binomial distribution. And here we will see that each trial is associated with two mutually exclusive and exhaustive outcomes. Once again, dear students, please remember the concept of mutually exclusive, which we had explained in course of the discussion on probability, the last chapter we had. So mutually exclusive, you know that if one event happens, if we have a head, so we are tossing a coin, if we get a head, that means we cannot get a tail, or we are not getting a tail. That means the occurrence of one event A actually precludes or prevents the occurrence of another event B. Similarly, exhaustive outcomes, you may kindly remember that exhaustive outcomes means that together, if there are 4 outcomes, 5 outcomes, or 6 outcomes, so I am rolling a dice, there can be 6 outcomes. Exhaustive means 1 out of the 6 outcomes must take place. So they are exhaustive, right? So therefore, in the case of binomial, the understanding is that we start with a Bernoulli process or a Bernoulli trial. And when a coin is tossed, we can see if either you get a head, so we denote it as a success, and occurrence of tail will be designated as a failure. So this is the condition number 1. Second condition is the trials are independent. And the third condition, as you can see, is that the number of trials is a finite positive number. That means we will have a number which is manageable, which cannot be, of course, it cannot be negative. It's a finite positive integer. And the probability of success for each trial will remain constant. Most important. So the value of P, it will be a fraction. So that it's a probability of success, and this probability of success, the value will remain constant throughout the Bernoulli trial. And therefore, if probability of success is denoted by P, then the probability of failure will be denoted by Q, and therefore Q is equal to 1 minus P. Right? I hope you are clear on this part. Now, we will see the probability mass function, and this is given by NCX, that is combination. So in this chapter, you can see that we are applying the knowledge which all of you have gained through the last so many sessions of LBC, the knowledge of combination, the knowledge of integral calculus, the knowledge of statistical description of data, chapter 13, the knowledge of the probability chapter 15, all these principles and these inputs which you have learned, now you will be able to apply that as we move into the further advanced discussion of this particular chapter. So therefore, we will see that binomial distribution, if this comes as a question many times, is it a uniparametric distribution or is it a biparametric? So if you look at the distribution, the probability mass function, Fx equal to n combination NCX, n combination x, p to the power x, q to the power n minus x. So here, there are 2 parameters, that is n and p. N is the number of trials and p is the probability of success, which will remain constant throughout the trials. Dear students, please note that if you know the value of n and p, then you can actually get the value of q also, and therefore the whole distribution, you can get the total distribution. So therefore, there are 2 parameters, only 2 parameters, n and p. So binomial distribution is known as a biparametric. Bi means two, bicycle, two wheels, two tires, so bicycle. So you can see biparametric distribution. Therefore, if you know N and P, you can find out the entire distribution. Please remember here, because questions in the exam, as sir guided all of you, that 5 to 6 questions are expected from this chapter. I can tell you that all the questions will be manageable. You can easily attempt the questions. It is quite simple, easy to understand, and not much of complicated calculations are there. It's more where you have to use your logic, your reasoning, your intelligence, and of course, memory, because some questions are based on the formula. The mean, the variance, in case of normal distribution, we have more number of properties and formula. So I request all students to please remember, I have prepared a chart so that you can get all the important formula at a glance, and that I will display in a short while so that you get everything in one shot. It is like a diagrammatic presentation of all the important points regarding these three distributions. So the mean of the binomial distribution is given by expectation EX, which equals NP, where N is the number of trials, P is the probability of success. And the variance is given by sigma square. You know what is variance? Variance is the square of the standard deviation. So the variance is given by sigma square, and you know here sigma square is variance. So sigma square is equal to NPQ. So its mean is NP and the variance is NPQ. And you know Q is equal to what? Q is equal to 1 minus P. Because Q is the probability of failure, it is equal to 1 minus the probability of success, right? So this is how you can see that we are getting the mean and the variance. And if you take the square root of variance, that is square root of NPQ, you will get standard deviation. As simple as that. Now, a very interesting point. It comes as a question many times. Since, please note, since P and Q, what is P? P is the probability of success. So it has to be a fraction. Of course, it can assume value of 1, or it can be 0 as well, you know, but usually it will be fraction. If it is a certain event, we will say probability 1. If the event is impossible, then we will say that it has 0 probability. But these are the extreme ends. These are the extreme points. Usually, probability will always be a fraction. Whether you call it probability of success or probability of failure, it is bound to be a fraction. And dear students, you know, fraction means it is less than 1. So you can see, since P and Q are numerically less than 1, or maximum it can be equal to 1, therefore, NPQ, very important point we are discussing, NPQ, that means the variance of binomial distribution, NPQ, will always be less than NP. Why? Because Q is a fraction. So NPQ is nothing but NP multiplied by Q, and Q is a fraction. Fraction means less than 1. So this gives us a very important principle and a relationship which we need to remember. And I request you to keep a notebook, a notepad beside you, whether electronic or plain simple pen and paper, and keep noting the important formula and the relationships which we will use for solving the questions. So variance of a binomial variable is always less than its mean. And another important relation, variance of X, that means NPQ, as you can see, will attain the maximum value, like a maxima and minima. Maxima, when P is equal to half, that is the probability of success is half, or 0.5, and Q is also equal to half, that is 0.5. So in that case, what will be the value of the variance? Variance is NPQ, but the maximum value of the variance you will get when P is equal to half and Q is also equal to half. So what is the value of NPQ? So I will write N into half, because both P equal to half and Q equal to half. So the product NPQ becomes N multiplied by half multiplied by half. That means you get N by 4, as you can see on the slide. So the maximum value of variance of X in case of a binomial distribution will be N by 4. Right? So these are important relationships. We can see once again the binomial distribution. Please note it is the probability mass function. Probability mass function, because it is a discrete variable here. And you can see once again the variable, the PMF, NCX, where N is what? You can see in details now. N is the number of trials. X is the success out of N trials. P is the probability of a success, and therefore Q is what? Q is 1 minus P. So NCX, P to the power X, Q to the power N minus X. And please remember that Q equal to 1 minus P, right? So very important points, and a lot of discussions we shall be doing on all the types of questions. Okay. So now let us look at the next point, right? And now we see the first question, right? If I toss a coin 20 times, so is it a binomial question on binomial distribution? Yes, because it says if I toss a coin 20 times, that means it has 2 outcomes, head or tail. What is the probability of getting exactly 10 heads? Exactly 10 heads. So you are tossing a coin 20 times, and the question is, what is the probability of getting exactly 10 heads? So here, please note N, that is the total number of trial, is how much? N gives you the total number of trial. In this case, how many times? It is 20 times. So we will write N equal to 20. The question asks you, what is the probability of getting exactly 10 heads? That means this is a question which asks you that for X equal to 10, X is the number of success. So we want to know how many times we are getting a head. So X equal to 10. And we also know that when you toss a coin, provided the coin is unbiased, not tampered, the probability of getting head is 0.5, that is half. And the probability of getting a tail is also 0.5, which is half. So therefore, you can easily calculate the probability here, and you get, the question is, what is the probability of getting exactly 10 heads out of 20 times tossing a coin? So here you see N is 20, it is finite. It is not a very large number. So therefore, we know this is the first hint or the indication that this problem is a question on binomial, not Poisson. And definitely it is not a question on normal. So when you get this question, you will easily appreciate and understand that this is a question on binomial. So I will use the formula NCX P to the power X Q to the power N minus X. And this is how we get the probability 0.176. So therefore, we see once again that the value in case of binomial probability distribution, the value of the mean, which is usually denoted by mu x, you can see mu x, also known as expectation EX. So this is equal to NP, where N is the number of trials, as you can see in the given example, and P is the probability of success. As we discussed in the last slide, once again, we do a recap. I'm doing it deliberately, the same point, so that it gets into your mind and you start taking note, because these are the important formula. So I will periodically recap and mention the same formula so that it slowly you are able to pick up and you will never forget. So variance is shown by sigma square, and sigma square equal to NPQ, as we saw. And we also saw that the value of variance will be maximum when P equal to 0.5, Q equal to 0.5, and therefore the maximum value of variance will be n into 0.5 into 0.5. That means it will be n by 4. So you can see here variance equal to NPQ. So therefore the standard deviation is what? It is the square root of variance. So you can see the square root of NPQ, I can write as square root of NPQ, and in place of Q, I can substitute Q by the term 1 minus P. Right? So you can see all the important formula on the left-hand side. Again, on the right-hand side, please go for a quick recap. This table. So binomial distribution, what type is it? It is a discrete. What are the two parameters it has? It has n and p. What is n? N is the number of trial. What is trial? Bernoulli's trial, you can see on the left-hand side on the slide, the number of times you can call it an experiment is conducted, or you can call it an activity is repeated. So I can, same simple words, tossing a coin could be an activity. So please remember, n is the total number of trials. P is denoted by success. Therefore, binomial distribution, probability distribution, is a discrete probability distribution. Number one, please remember. Point number two, it is here what you see, NCX, P to the power X, Q to the power N minus X. This expression, this is equal to what? It is equal to Fx. This distribution, this expression is known as the probability mass function. Okay, so therefore we can see the PMF, probability mass function formula, NCX, P to the power X, Q to the power N minus X. Please note this point here. Next point, range of X. So X can take values from 0 till N. Please note once again, dear students, binomial, in case of binomial distribution, the variable cannot take any negative values. The variable cannot take any fractional values. That is why we call it a discrete probability distribution, because the variable can assume only positive. So 0, 1, 2, it is integer, whole number. And you can see it goes up to n. N signifies finite. But in case of Poisson distribution, you will see that in case of Poisson distribution, the number of trials or experiments will be very large. And therefore, X will range from 0 to infinity. But in case of binomial, it is finite. So we have up to n. Right? I hope you can understand the table. So I have tried to simplify each of these this particular distribution into a tabular form, which I'm sure you will be finding it easy to grasp, understand, retain in your mind, and apply when you sit for the exam. So next point, P, mean. What is the mean of binomial distribution? Mean, or mu, is denoted by the product of n and p. N is the number of trials, p is the probability of success. Variance is what? Sigma square equal to NPQ. And therefore, the standard deviation equal to square root of NPQ. So you can see all the important properties or the key formula which you need to know on the binomial probability distribution at a glance in one particular table. Now we look at another unique property of the binomial distribution. If X and Y are two independent variables, so it is given that X follows a binomial distribution. Please see on the lower left-hand side of the slide, additive property. So questions can come on this property as well. So X and Y are two independent variables. They are not related. And X follows a binomial distribution with two parameters, N1, that means the number of trials is N1, and probability is shown by P. Then we have another variable Y, and you can see that in the case of the second example, which you can see here, Y is also binomial distribution. सो यहां पे x और y ये दोनों जो है, these are दोनों ही binomial distribution फॉलो कर रहे हैं, and we can see that x has a parameter n1p and y has a parameter, y का क्या parameter है, n2 and p. So if x and y are two independent variables with these individual parameter, now the important result is x plus y, the sum of these two independent variable, ये जो x plus y, this will also follow, ये भी binomial distribution follow करेगा, और इसका parameter क्या होगा, it will be the sum of n1 plus n2 and the p probability will remain the same. So if you are given a simple question based on this additive property, we have two distributions, both are binomial, and say x and y are two variables. X has a parameter, मान लीजिए n1 equal to 40 and probability p equal to say 1 by 5, and we have another say binomial distribution y, and in case of y, n2, yani number of trials, as you can see, say n2 is 30 and the probability is 1 by 3. So x plus y, uska parameter kya hoga? What will be the parameter of x plus y? So x plus y parameter will be simply the addition. So we will write that the parameter of x plus y will be what? The number of trials will be n1 plus n2. यानी पहला जो पैरामीटर है, it will become n1 plus n2, that is 40 plus 30, which is 70, and the probability p will remain as it is. Now we see, of course, we have the same probability. We have assumed same probability, 1/5, 1/5 for both. So the probability will be same. So two distributions, x and y, which are having differences in the number of trials, first distribution having n1 and second distribution having n2, we are assuming same probability. Let us keep it at 1/5. So in that case, the sum of x plus y will also follow a binomial distribution, but now the parameter will become n1 plus n2, and the second parameter, that is p, the probability of success, will remain the same. So this is the additive property. Please keep a note of this one as well. So therefore, or एक बार, once again we'll look at the quick recap. Variance का limit in case of binomial distribution, the variance is always less than the mean. Please remember, mean is mu, np, and variance is npq. But we know q is always a fraction. Therefore, mean is always higher than variance in case of the binomial distribution. And the second is maximum variance. This I have repeated for your kind understanding and attention, that the maximum variance कब होगा in case of binomial? तब होगा जब probability of success is equal to probability of failure. ये तभी हो सकता है जब p is equal to q और दोनों का value half or 0.5. So you can see the maximum variance. Variance का formula क्या है? npq, n into p into q. The maxima will take place, यानी maximum value of variance तब मिलेगा जब probability of success, यानी p, is equal to half or 0.5, and therefore q probability is also half. So therefore npq, ये जो product है, if I write it, it will become n into 0.5 into 0.5. Or you can say in this way, n multiplied by half multiplied by half. क्योंकि p का वैल्यू भी हाफ है, या 0.5 आप कह सकते हो, q का भी सेम वैल्यू है. So n into p into q, it comes to n by 4, या फिर 0.25 n. A 0.25 into n is also equal to, we can say it is n by 4. So maximum variance, agar exam mein if this question comes, please confidently remember that the maximum variance in case of the binomial probability distribution will be equal to n by 4. Now we move to the next important discussion, a practical example. Sir, in the very beginning, Dr. Ravi sir gave you a very important message that binomial distribution is used in real life, in the world of economics, finance, in the world of business. So let us see a practical example. So the example is regarding banking. Now in mathematics, you have very good understanding of financial mathematics. You know what is annuity. You know what is meant by say for a recurring deposit. All these things you know. That is part of our curriculum. So you know that when a bank is a simple interest, compound interest, you are definitely having good knowledge of that. So that's why I have taken an example of practical application of binomial through a example. बट दिस एग्जाम्पल केवल थियोरिटिकल नहीं है, ये एक प्रॉब्लम है जो हम लोग सॉल्व करेंगे स्टेप बाय स्टेप. इट इज एक्चुअली अ मैथमेटिकल प्रॉब्लम बट related to the banking industry. Now you can see commercial banks, they give loans. You know, whenever I take any bank sanctions a loan, there is always a probability that the party may not repay the loan. Sometimes you must have heard about the term called bad debt. You know something called NPA, non-performing asset. So in real life, now I'm sure you will not only do well in this, but on this chapter, but you will start taking interest in statistics, and this will definitely help you throughout your journey in CA and even as a professional. So you can see the application. Binomial is used for risk profiling. कैसे risk profiling होता है? Please see. When loan defaults are independent with stable probability, that means the default of loan remains same. Binomial distribution का एक बहुत important assumption ये है, which sir mentioned in the beginning, that the probability of success, or in that case the probability of default, will remain same. Number of trials are finite, यानी एक अकाउंटेबली फाइनाइट. आप सोच सकते हो कि ओके एन 10,000, 5,000, 1,000, 100, 50, whatever number which is finite, it's not an infinite number, and the probability of success remains the same. So here, in case the loan default probability is stable, risk managers use this principle to find out the chances of multiple bad loan. जैसे आप लोग जानते हो bad debt, you are also creating provision for bad debt, provision for doubtful debt. Similarly, when a bank provides a loan and if the loan turns out to be bad, then the banks also have to create a provision, and this provision percentage, everything is guided by the RBI prudential norms. So let us see a practical example how banking sector, not in India only, but throughout the world, they use this practical binomial probability distribution, and they are able to find out the exact number or the probability of defaults. Question is like this, practical example: a bank knows from historical data that there is a 10% chance that a personal loan application will default. That means the probability of default is 0.1. Now the bank is issuing 4 independent loan, यानी n equal to 4, यानी trial, number of trial ये 4 है. So a finite number, of course, very small number. Question is, what is the probability that at most one borrower will default? At most one borrower. At most one borrower means, you can understand, मतलब मैक्सिमम एक बोरोवर डिफॉल्ट करेगा. इसका 2 पॉसिबल आउटकम या 2 यू कैन से एलिमेंटरी इवेंट हो सकता है. एक है कि कोई भी बोरोवर डिफॉल्ट नहीं कर रहा है, एंड द सेकंड सिचुएशन or the second possibility could be only one borrower defaults. Please see the question once again. It is written, what is the probability that at most means 0 and 1. That means probability of having 0 defaults and the probability of having exactly 1 default. Once you add it up, you will get this answer to the question, what is the probability that at most 1 borrower defaults? So you have the question आपके सामने है, you can see the value n का क्या वैल्यू है, n क्या है, n है नंबर ऑफ ट्रायल। बाइनोमियल डिस्ट्रीब्यूशन क्या है, NCX P to the power x Q to the power n minus x। n का वैल्यू क्या है, n is carrying the value 4, p का वैल्यू क्या है, p is 0.1। We already have discussed that binomial probability distribution is a biparametric। दो पैरामीटर होता है, n और p। अगर आपने n और p का वैल्यू निकाल लिया, that means you know the full distribution। So therefore, with these two important information, let us see the step-by-step calculation। So at most one means we have to find the probability of exactly 0 default as well as 1 default, exactly 1 default। So therefore the parameter, as I mentioned, n is 4, p is 0.1। So q क्या है? Here p is the probability of default, यानी लोन लेने वाले आदमी डिफॉल्ट करेगा, वापस रिपेमेंट नहीं करेगा। So what is the probability of q? Q is what? Q is just the complementary event, so 1 minus p। So q का probability क्या है? 0.9, 1 minus 0.1। When x is 0, first situation, please see, when x is equal to 0, so the probability mass function अभी क्या बनेगा, n के जगह में हम लोग 4, we will write 4, and in place of x we will write 0, because we want to find out the probability of 0 defaults। So our PMF, as you can see here, the first one, I'm just trying to draw your kind attention here, px equal to 0, this becomes 4c0, c matlab combination, 4c0, 0.1 to the power 0 into 0.9 to the power 4। क्योंकि दोबारा आप चेक कर लीजिए प्लीज, check the probability mass function of binomial, it is NCX P to the power x Q to the power n minus x। Here x is 0, so P के ऊपर the power is 0 and Q के ऊपर जो है इंडेक्स, आप इंडेक्स अगर बात करें, इंडिसेस की बात करें, it is 4 minus 0, so it is 4। So therefore we are getting just if you simplify, you will get the probability of having 0 default is 0.6561। Now we go to the last possibility, if there is exactly 1 default, that means here x will have the value 1। So the probability that x equal to 1 is given by 4c1, x अभी 1 है, x is 1, so I will write 4c1 p to the power 1 q to the power 4 minus 1। इसका मतलब क्या है, 4c1, as you can see, p का value is 0.1, so I have written 0.1 to the power 1 multiplied by 0.9 to the power 4 minus 1, that is 3। In this way, the probability of having exactly 1 default works out to how much? 0.2916। So students, please note the total probability of having at most 1 default. Now we are just adding this. You can see p is less than equal to 1. This is how we show x is less than equal to 1. That means x, yani number of default, will be less than equal to 1, either less than 1। अब लेस देन 1 एक ही हो सकता है, 0, क्योंकि ये बाइनोमियल है, यहां पे x का तो कोई फ्रैक्शनल वैल्यू नहीं होगा। So either we see it is p equal to x less than equal to 1, that means p is either such that x equal to 0 or it is x equal to 1, and therefore you can see the probability comes to 0.9477। that means the interpretation is there is a 94.77% chance that the bank will face a highly manageable scenario। That means at most 1 default hone ka probability is that means at most 1 means what, 1 or less than 1। So there is a 94.77% chance that the bank will face a scenario of 1 or fewer defaults। That means the number of default is less than 1 or equal to 1। This has maximum probability, right? So in this way, by using the principle of binomial distribution, we can see how the problem has been solved। Now, dear students, we move to the second example, the second type of probability distribution, but this is also a discrete probability distribution. So we have the Poisson distribution. You can see the photograph of Simon de Poisson, who created this important probability distribution. And we can see the mass function. X equal to Px equal to e to the power minus m multiplied by m to the power x divided by x factorial. So we can see this is the probability mass function, क्योंकि binomial is also, Poisson is also an example of a discrete probability distribution. So the famous mathematician and statistician Simon Poisson from France, he introduced this particular distribution. और किसके लिए डिस्ट्रीब्यूट ये इन्वेंट किए थे, डिस्कवर अगर आप कहोगे हाउ, व्हाई डिड ही, अंडर व्हाट अर्जेंसी ही डेवलप्ड दिस डिस्ट्रीब्यूशन टू फाइंड आउट द नंबर ऑफ डेथ्स ड्यूरिंग द Prussian war by due to horse kicking. Horse were kicking the soldiers, and soldiers and other horses probably died. And Poisson, Simon de Poisson, noted that he was told that find out a distribution, so that you can just think of the historical background. So you can see he was born in 1781, passed away in 1840. So you can see under what circumstances he created this distribution. Now, Poisson means 2-3 important feature, पहचान, जिसको देखने से आपको तुरंत पता लग जाएगा कि here we have to use Poisson, यहाँ पे binomial चलने वाला नहीं है. तो first क्या हम लोग देखेंगे, the total number of events will be very large. In the case of binomial, we were observing, शायद आपने नोटिस किए होंगे कि in case of binomial n का जो वैल्यू है वो काफी कम है, it is within limits. But if you look at Poisson, what is happening? Please note, total number of events is large. Ravi sir, in the initial part of the session, he gave you the entire snapshot, and he mentioned, I'm sure you have noted that, कि Poisson distribution is for that scenario where event, यानी trial का संख्या बहुत बड़ा है. It's a huge number of trial, but the probability is very less. यानी probability, एक event का probability बहुत कम है. So Poisson distribution is used to find out probability in case of a rare event, जो एकदम rare, जो होने का chance बहुत कम है. And therefore, please note, in case of Poisson also, x will assume only non-negative value, very similar to the binomial. Non-negative, यानी positive values. So therefore, Poisson का what is the एकदम जो हम लोग essence कहते हैं या फिर crux कहते हैं, what is the exact heart of Poisson? Poisson कब हम लोग apply करेंगे? It involves occurring number of outcomes. So when you see the number of trial is very large, and if you get a problem in the question which deals with a particular event, like as I mentioned, number of phone calls per hour, number of visitors who are entering a particular office, number of passengers who are entering the train, number of printing mistakes in a book. So we can see either time interval या फिर एक spatial interval या एक range दिया हुआ है. So आप देख सकते हो probability calculate करने के लिए in the real world we might be getting different scenario. अब coin tossing में भी probability है. Similarly, in the last session I had discussed कि insurance companies, when they find out the premium amount, कि भाई कोई आके एक life cover लेने का सोच रहा है, what will be the premium? So insurance company will calculate the probability that this person will live up to the age of 60, 70, 80, 90. और उसके लिए mortality table निकलता है. So you can see probability in the real practical world of business, finance has different types of situation where probability has to be calculated. So therefore, please look at these 4 points which I have which is there in the slide, I've mentioned here, Poisson distribution will always be applied when the number of outcomes is given in a time interval, per hour, per day, per year, per month, or it could be within a region or a space. It is like a rate. How many people are entering? How many mistakes per page? How many people entering per hour? How many defects in a production per 100? So इस तरह का अगर आपको प्रॉब्लम दिखता है, it could be an application of Poisson. It is not going to be an application of binomial. And एक बहुत important point, if Poisson distribution, if in case of binomial we saw that there are two parameters n and p. N, you remember we said that n is nothing but finite. That's why x can assume values from 0, 1, 2, 3 up to n. N is finite. लेकिन अगर n और ज्यादा हम लोग बढ़ा दिए, if the value of n goes up, so we are dealing with a binomial distribution where there are two parameters n and p. If n becomes very large and p becomes small, smaller, smaller, so it is called limiting factor. Limiting. Please think of the concept of limit, continuity, which you learned in the session on differential calculus in your calculus chapter. So Poisson distribution is a limiting version of binomial. यानी binomial distribution का जो दो important parameter है n और p, n अगर हम लोग बढ़ाते जाएंगे, यानी number of trials from finite it becomes larger, uncountably large, and p यानी probability of success, if it becomes smaller, that means rare event, probability जितना घट रहा है इसका मतलब है उतना rare हो रहा है. For example, probability of a toss, coin मैं toss कर रहा हूं, probability of a head is half, but the probability of, say for example, a printing mistake in a textbook, if you see, the chance is much less. So therefore p becomes smaller. That is why Ravi sir mentioned in the very beginning that Poisson is used for rare events. So आपको दो तरह से आपको समझ में आ जाएगा कि क्वेश्चन में जो प्रॉब्लम दिया है, here which distribution formula to be applied. The moment you see कि क्वेश्चन का पैटर्न देख के आपको लग रहा है कि this is a rare event. It is not a simple event with two outcomes. It is rare. Plus, if you see large number of trial, yani n has a large value, so then you can understand that here a binomial distribution actually becomes a Poisson. That means the limiting case of binomial, when n becomes large and larger and p becomes smaller and still is infinite small, very rare. So then the binomial distribution becomes Poisson. So please remember, Poisson distribution is said to be a limiting version of binomial. And now we see the mass function once again, e to the power minus m multiplied, आप देख सकते हो, m to the power x divided by x factorial. So यहाँ पे e है क्या? E is nothing but the Euler's constant. ये एक mathematical constant है, जैसे आपको पता है pi. Pi हम लोग लिखते हैं 22/7, 3.1415 and so on. So you can see Euler का जो value है, Euler's constant, it is 2.718, so on. In the problem, in the exam, in most of the cases, you will find E, the value of E will be given. So you don't have to do much computation on this part. And E का और एक पहचान क्या है? You have completed the discussion, the chapter on logarithms. So you know that logarithm, जहां पे हम लोग natural log की बात करते हैं, so it is the base of the natural logarithm, that is the E. Now we look at the properties of both binomial and Poisson, because these are discrete probability distribution. यहाँ पे क्या होगा? The fx, यानी function of x, the probability, this will range from 0 to 1. The minimum can be 0, the maximum can be 1. I'm sure you will agree on this. Second, sigma fx equal to 1. इसका मतलब क्या है? कि एक डिस्क्रीट वेरिएबल, बाइनोमियल पॉइजो दोनों में हम लोग डिस्क्रीट वेरिएबल की बात कर रहे हैं. दैट मींस द वेरिएबल विल ओनली अज्यूम स्पेसिफिक वैल्यू, maybe only full number, whole number, positive whole number. So since it assumes discrete value, हर वैल्यू के लिए क्या प्रोबेबिलिटी है? That means probability that x equal to 1, probability that x equal to 2. In this way, probability x equal to n. So ये n जो है, n situations, हर situation के लिए we can actually find out the exact probability. So you can just mentally अब सोचिए, mapping करिए. We have to also use our mind. AI systems, technology are good, but ultimately, please remember your EI, emotional intelligence. Man has created AI. AI has not created man. So always be dependent on first on your brain, then look at technology. Now, mentally a map karo that think of x-axis, y-axis. In the x-axis, different values are given. जो हम लोग ग्राफ ड्रॉ किए थे in chapter 13, histogram. You may remember line diagram, ogive. याद आ रहा है आपको? x-axis. So वहां पे you see individual probability आप plot कर रहे हो. So the sum sigma fx, the total probability, will be equal to 1. That means the probability of x assuming different value, iska sum total will be equal to 1. So this is the second important relation. And the third relation you can see is mu is given by sigma x into fx. And in the case of binomial, we have already seen mu यानी mean का value है np, variance का value क्या है npq. Now we will look at the Poisson distribution again. Please see on the lower side, you can now see the Poisson distribution. So now we look at here, we see the probability distribution of Poisson. So here, the PMF, the probability mass function, equal to e to the power minus m. M we can also write as lambda into t, where lambda is the rate and t gives you the time. And lambda is the average number of outcomes per unit time, you can see rate. So in this way, you can get the probability mass function of the Poisson distribution. And we have also discussed the important properties here. Okay. Now we will go into the next point here. Okay. Students, please concentrate and don't start writing lot of chats. Please understand first. This is a very important topic. Please give focus and concentration. I'm sure by the end of the session, all your questions will be answered. Please also concentrate and don't start writing all whatever comes in your mind, all questions. No, first you see, we will cover each of them. Right. Now you look at the lower side, you can see on the right hand side events. So here, therefore, for Poisson also, events occur at random and events will occur at a constant rate. That means lambda will be constant. So these are the important features of the Poisson distribution. We will see later that Poisson distribution ka jo skewness, right? I'm sure you know what is skewness. We will show it again later. So Poisson जो है, it will be little asymmetric. ये पूरा symmetric curve नहीं होगा. It will be mildly positive. In case of Poisson, we will see skewness will be more than 0. We will see that later. Now we will move on and see an entire example of Poisson, practical example. Let us see. If calls to your cell phone follow a Poisson process, और यहाँ पे constant rate is what? Lambda. So please see once again, if I go back to the last slide, slide number 6, we are on slide number 6. So if you see here, you will observe that e to the power minus m, ये m क्या है? M is the mean. And you will see m is also the variance. So in case of Poisson, it is uniparametric. बाइनोमियल का दो पैरामीटर है n और p. Poisson का केवल एक ही पैरामीटर है, only m. And here the mean is also shown as m and the variance is also m. So once you know m, you get the full probability mass function. इसका मतलब यही है that in case of Poisson, it is a uniparametric probability distribution. Now let us look at this example. If calls to your cell phone is given, आपको एक the probability or the rate of call is you average, on an average you get 2 calls per hour. What is the probability that if you forget to turn off your phone in a movie hall where you are spending 1.5 hours, what is the probability that your phone will ring during that time? Beautiful example. So you can see phone calls to the phone, calls coming to your phone. So we always, in movie halls also, even though we keep it in a silent mode or in a vibrated mode, but we always frequently check. That is a different story. We always see kahin koi WhatsApp to nahi aaya, important call to nahi hai. And if we don't get calls or WhatsApp, then we think कि भाई कहीं network तो खराब नहीं है. Is it working? So that is the mentality or the psychology part. But the point here is the given question says that you are getting 2 calls per hour. What is the probability that if you forget to turn off the phone, your phone will ring during that time? So here, since the fact of the question clearly says it is a case of event per hour, so we will apply Poisson and we can see here the phone rings during that time. Iska matlab kya hai? How do we find the probability? Phone ringing, that means either you are getting 1 call or 2-3 calls. If 2 calls you get, the phone will ring 2 times. If you get 3 calls, 4 calls, 5 calls, 10, 50 calls, you are very busy, say a busy executive, you might get multiple calls. So probability that your phone will ring, iska complementary event kya hai? What is the complementary event? That means the phone will not ring. Phone will not ring when you do not get a call. That means when x equal to 0. Please try to understand this. That means here, the question is the probability we have to find that your phone rings during that 1.5 hours. Yani x should be 1 and more than 1. X क्या है? Call coming. यानी x एक बार अगर एक भी कॉल आया, the phone will ring. अगर 10 कॉल आएगा, तब भी फोन 10 बार अलग अलग टाइम पे रिंग करेगा. So the question asks you, your phone rings during that time. Very intelligent question. So you can see here the probability we have to find x larger, that is greater than equal to 1. How do we find it? It is nothing but the complementary event that the phone will not ring. That means एक भी call नहीं आएगा, यानी x equal to 0. 0 calls are coming. That is no call. So no question of the phone ringing. And therefore, we will first find Px equal to 0. We will use the probability mass function given in the Poisson process. So यहाँ पे आप देख सकते हो, in the working out, please see e to the power minus, we know the formula is e to the power minus m to the power x divided by x factorial. Here, instead of m, we are given the lambda, that is the rate and the time. Time क्या है? 1.5 hours. Rate क्या है? 2 call per hour. So therefore, m can be broken down as lambda into t, where lambda is 2 and t equal to 1.5. So this is the calculation, e to the power minus lambda into t into, you can see, lambda into t to the power x, because the PMF is what? E to the power minus m into m to the power x divided by x factorial. यहाँ पे x का value 0 है. So you can see here 2 into 1.5 to the power 0, because no call will come. यानी x का value 0. नीचे भी 0 factorial, but you know 0 factorial equal to what? 1. So finally we are boiling, this boils down to e to the power minus 3, and you can see the tables, and this is 0.05. That means the probability that the phone will not ring. Please note, probability x equal to 0 means what? ये जो probability we have got 0.05, ये क्या इंडिकेट कर रहा है, ये क्या समझाने का कोशिश कर रहा है, ये क्या प्रोबेबिलिटी वी हैव ब्रॉट आउट? द प्रोबेबिलिटी व्हिच वी हैव वर्कड आउट इज p प्रोबेबिलिटी ऑफ x इक्वल टू 0. दैट मींस x क्या है? x इज द इवेंट दैट योर फोन रिंग्स. That means x equal to 0 means you will not get a phone call, your phone will not ring, and the probability is 0.05. Therefore, dear students, if the probability that the phone remains silent, that means not a single call comes, you know the probability is 0.05. So what is the complementary event? यानी इसका opposite क्या होगा? Probability that a call will come. कैसे निकालेंगे? सिंपल सी चीज है, 1 minus 0.05. Right? I hope you are able to follow. And therefore, you can see the probability x is greater than equal to 1, therefore means 1 minus 0.05, yani 95% chance. So I hope you can see, using practical examples, we are able to find out the probability. Now, how many phone calls do you expect during the movie? By movie ka duration is given, it is how much? 1.5 hours. And we know the value of lambda. How many phone calls can you expect? Ye question is giving you the hint. Expect means what? Expectation. Expectation हम लोग कैसे लिखते हैं? EX. Expectation का और एक और meaning क्या है? It is mean. So we have to find out the mean. That means lambda into t. And therefore we are getting expectation of x. That is lambda into t. Here lambda is 2 क्योंकि घंटे में 2 बार फोन आने का चांस है. Lambda is 2 and duration time is 1.5. So the expectation of x is 3. That means you can expect to get 3 calls. Finally, as I mentioned, Poisson approximation to binomial. In other words, you may get a question like this, that which distribution can be seen or can be said to be the limiting case of binomial? Answer will be Poisson. When binomial ka jo n hai, number of trial, where, as I mentioned earlier, the number of trials becomes indefinitely large. Yani n is now tending towards infinity, ek limiting concept. Parallelly, n बढ़ता ही जा रहा है. It's going on increasing. Just imagine. On the other hand, p, the constant probability of success, is becoming smaller and smaller. So two reverse process, n becoming larger, p becoming smaller. And if you multiply this np, ये np हम लोग बाइनोमियल की बात कर रहे हैं. बाइनोमियल डिस्ट्रीब्यूशन में अगर n की संख्या बढ़ता ही गया and p का वैल्यू अगर घटता जाए and the product still becomes finite, then what will happen is the binomial distribution can be approximately equal to a Poisson distribution, क्योंकि Poisson का जो फर्स्ट पैरामीटर, फर्स्ट क्राइटेरिया, वो क्या है? याद करिए क्या है? फर्स्ट क्राइटेरिया है बहुत सारे एक्सपेरिमेंट्स. That means n will be large, and here we are assuming that binomial का जो n है, अगर n बढ़ता गया, so we are meeting the first objective of Poisson. Second feature, खासियत of Poisson क्या है? Rarely, यानी probability बहुत कम होगा, यानी p का वैल्यू बहुत ही छोटा है. So you can see number 2, very important limiting concept, that from a binomial probability distribution, as n increases indefinitely, goes towards infinitely large, and p becomes smaller, that means we are now dealing with a situation where the probability is very small. That means the event is rare. But on the other hand, a number of trials are taking place. So in that case, please remember, Poisson distribution will be the approximation, or you can call it the limiting factor of binomial. And in that case, that particular binomial distribution's parameter will now become m, and m will be n into p. So this is very important. And finally, the additive property of Poisson. So in case of Poisson, same thing as we saw earlier in the discussion of binomial, same concept. That means two variables are there, x and y, दोनों independent variable है. We know Poisson distribution यूनिपैरामेट्रिक कहलाता है क्योंकि इसमें केवल एक ही पैरामीटर है, that is m. m is also the mean, m is also the variance. So दो वेरिएबल है x और y. x का पैरामीटर है m1 and y का पैरामीटर है m2. then the sum of x and y, say it is equal to z. Z भी क्या Poisson follow करेगा? Will Z also follow the same Poisson distribution? And number two, what will be the parameter of Z? So just additive, इसीलिए ये property का नाम है additive. We are adding. So Z will also follow Poisson distribution with parameter M1 plus M2. So this will hold good for two independent variables. Okay, now we move. So I hope you are able to understand, and slowly, see, every chapter, these are the more difficult chapters. Last few chapters after this, we have correlation regression, and the last, I guess, is index numbers. These are comparatively a little difficult. So focus and concentration required. Right? So the first chapter of statistics and the chapters we are now doing, we are going up level-wise, complexity-wise, right? So more focus, more concentration, more practice, more thinking. Even after the session is over, just sit down with pen and paper and think. Discover yourself. You will never forget the principles in your life. And my dear students, do it for all papers, all subjects. Think on the subject, fall in love with the subject, because these subjects will stay with you forever. CA Foundation, whatever subjects we are studying, almost same subjects are there in intermediate and final, और ये सारे subjects पूरी professional practical papers. So therefore start falling in love, get the excitement, get the feeling. Once you love the paper, love the subject, no stopping. Probability of success आपका 1 होगा, याद रखिए. Now we come to the Poisson application. Printing mistakes, क्या application है? Number of meteorites greater than 1 meter. That means please see, here n can be very large, but the probability will be very small. Number of laser photons, atomic structure, atomic theory, many of you might be knowing. So number of road accidents, probability of a single road accident बहुत कम है, but the number of events are huge. Also, you can see number of radioactive elements per minute in a fusion process. So all these, especially atomic reactors, yes, they use Poisson distribution. Number of demands, now we come to economics. You remember Ravi sir said in the very beginning that distribution, probability distribution, theoretical distribution has ready applications even in economics. So number of demands per minute for a healthcare center, number of tropical cyclones in a season. Please note these different applications. ये हर जगह में x जो वेरिएबल होगा, क्या वो फ्रैक्शन हो सकता है? नो. क्या वो नेगेटिव हो सकता है? Number of road accidents, can it be negative? No way. Number of clients visiting a ticket selling counter in a metro station, it will only be positive integer. Zero हो सकता है, कोई नहीं आया, ये भी हो सकता है zero, but it can never be negative. So you see discrete. Number of goals in a World Cup. So already all of us have been glued to the TV screen for the World Cup. So yes, number of goals in a World Cup. Yes, can it be fractional? No. Can it be negative? No. Number of cars passing a crossing. So these are the application. और एक टेबल मैंने जो बनाया, same for binomial, we see for Poisson. Everything in a snapshot. Poisson distribution, what is the type? So dear students, it is. So all students must remember that just like binomial, Poisson is also a discrete distribution. Parameters क्या है? Yes, it is only one parameter, m. हाँ, m को जरूर हम, we can break it into lambda. M can be equal to lambda into t, where lambda is the rate of an event per hour या फिर per unit time. अब per hour भी हो सकता है, per day it can happen, per month it can happen, per year it can happen. But it's ultimately a unit of time. So the type is discrete. Please remember, in this way, try to, these things should be absolutely ingrained in your memory, right? Think, ask yourself randomly that, okay, binomial, we know the features. अब Poisson का क्या feature है? क्या ये continuous है? नहीं, ये discrete है. क्या ये multiple parameter है? नहीं, uniparameter, केवल m. But m can be written down as lambda into t. क्या इसमें PMF होगा या PDF होगा? Well, दोस्तों, ये है PMF, probability mass function, because it is discrete. Range क्या है x का? In case of binomial, हम लोग देख रहे थे, we saw that x can assume values from 0, 1, 2, 3 up to n. But here, dear students, please see range of x. Please note going to infinity because n can be very large. That is the feature of Poisson. In case of binomial, n is finite. In case of Poisson, number of trials or number of events is huge, large. Mean क्या है? Mean is m. In case of binomial, mean क्या था? Mu. In case of binomial was n into p. So हमेशा ये तीनों डिस्ट्रीब्यूशन, ये तीन दोस्त आपका नए दोस्त बन रहे हैं. सबको पहचानना है, सबको जानना है, सबका pros and cons भी समझना है. Look, we are making new friends. Like you remember in the earlier chapter, I had said that yes, we met a champion. Say standard deviation was a champion. You may remember that it is one of the best we saw as compared to mean deviation and range. So we are meeting new friends, and these are friends for life. Variance क्या है? Variance is m. Variance is given by sigma square. That means Poisson is very easy because you just have one parameter, और यहाँ पे mean is equal to variance, and therefore the standard deviation is square root of m. Now, students, we move to the next one, a practical industry example. So I have approached it from all corners, possible corners. First, we are getting all the principles, important formula, features, additive property. Then we have seen one complete numerical, the phone call wala numerical. अभी हम लोग देखेंगे industry angle से, लेकिन number problem ही करेंगे. So industry के ज्ञान नहीं होगा. इसमें problem, but it is colored from the industry perspective. जैसे हम लोग in the पिछले example, in the last example for binomial, we had used industry example, bank, default of loan. See here, IT service desk. क्या application है? And then we will see the numerical problem. Let us see the application of binomial of Poisson. E-commerce website. So e-commerce is an inseparable part of our life, right? So many apps, e-commerce, quick commerce. So e-commerce website and tech companies use Poisson to manage the server capacity. Plus, you know, her company का customer care एक separate department है. Customer care का काम क्या है? Number of calls coming per minute. Think Poisson distribution. Number of grievances, number of emails. Okay, number of payments coming per minute. Payment gateway. So these are following a rhythmic pattern, right? Incoming server hits. Similarly, number of website, number of visits per minute. एक website या portal में how many visits, how many people are landing on that website. This could also is like a distribution. Let us see the practical example. Online brokerage platform receives an average of 2 critical system glitch per day. यानी यहाँ पे क्या है? Per day. यानी time scale is not per hour, it is a per day. Okay, perfectly okay. M is 2 because it is given 2 critical system glitches alerts per day. Now the question is, what is the probability that the IT team will face exactly 3 glitch alerts tomorrow? अभी तक mean है, average है, expected value है 2 critical systems, 2 critical system glitch. Now the question is exactly 3 glitch का alert कल आएगा. Exactly 3, please see in bold. So now we look at the step-by-step calculation. So I hope you are listening, following, focusing, concentrating, and also taking some notes wherever possible, either on your iPad or tab or whatever you feel like your physical notebooks. Parameters, so you can see here in case of the step-by-step calculation, we have parameter is only one, uniparametric, so m. So m is 2. We have to find out number of occurrences here, x is 3. So the formula here we know e to the power minus m into m to the power x by factorial x. Once we translate and substitute the values, we are actually getting e to the power minus m, that is e to the power minus 2 into 2 to the power 3, because we know the probability mass function we know is what? It is nothing but e to the power minus m into m to the power x by x factorial. So here we have to find exact 3. The question clearly says exactly 3 glitches. So you can see we are arriving at the answer for P probability within bracket क्या लिखा है when x equal to 3. उसका probability क्या है? यानी 3 glitches का एक alert आएगा per day. और वो भी कल, tomorrow. So using the formula, we are getting Px equal to 3, which is 0.1804. That means in terms of percentage, we can write business interpretation. इसका business interpretation क्या है? There is a 18.04% chance that technical team will receive exactly 3 high priority service alerts tomorrow. In this way, we can calculate up to 3, 5, any number. Okay. So I hope you are clear with Poisson, and now we move on and now proceeding to the normal or the Gaussian distribution, our third and the last friend whom we are meeting and understanding. You can see for every distribution, my humble dedication to the founder of these distributions. We cannot forget their name, and we at least should know who created this distribution. So Bernoulli, and then we saw Poisson himself, and now we have Carl F. Gauss, the creator of normal or Gaussian distribution. Roughly, you can see all these three great statisticians from Europe. They lived in the contemporary age, all 18th century to 19th century, right? So normal or Gaussian distribution, most, I will say, like a champion. Of course, there are other distributions, students T distributions, chi-square, those are outside our syllabus. But normal distribution is seen as a champion. So let us see the normal distribution. But please remember, now we move from discrete to continuous. Because normal probability distribution is actually an example of a continuous distribution. And now we will see it deals with continuous random variable. And therefore, since it is continuous, अभी हम लोग देख रहे थे for binomial and Poisson, we saw that the value is always discrete. A number of phone calls, it can always be whole number and positive. It cannot be a fraction. But in case of Poisson, in case of normal or Gaussian distribution, the variable can assume any value within a range. That means, as you can see on the first bullet point, it is impossible to distribute the total probability among all the different mass points, because between any two unequal values, the variable x can assume infinite number of values. अब सोचिए between 1 and 2, अब कहने से तो एक के बाद दो ही आएगा, but if you look at the difference between 1 and 2, the difference, the intermediate values can be infinite. For example, 1 point, after 1 point, if you write 10,009, 999, instead of 10,000, still it is not equal to 2. So there could be n number of, and I hope you can understand the beauty of mathematics and statistics. So you can see slowly that normal distribution mein kis liye, why we call it continuous probability distribution, and we will see that the probability distribution, therefore, in normal distribution, we cannot assign individual probability for individual values of the variable x, for the simple reason that the number of values which x can assume is simply infinite. Infinite values, we can't assign individual probability. So kare kya? Solution kya hai? Gauss, the celebrated statistician, mathematical guru, he said, why not use the concept of integration? Curve banayenge, the area within the curve, that will give us a density, not a mass. We will get density. Density kya hai? What is density? We always say density of population. 10,000 people per square kilometer. Density of matter. So weight of the matter, mass kya hai? Gram, milligram, kg, kilogram, quintal. It is unit of mass. Density kya hai? Mass per unit volume. I hope you are getting why density. So be absolutely clear. So as a student of mathematics myself, I always try to think mathematics, statistics. हर विषय में हम लोग सीख ही रहे हैं. We are all students. So I always think that why, I used to think why density word is used. Mass or density में फर्क क्या है? Why the binomial is a probability mass function, and why normal distribution is called probability density function? दोनों में अलग क्या है? So slowly, I hope you can understand the concept of density. So therefore, in this case, you can see what the solution we will do in case of continuous random variable. Therefore, the variable can assume any value and infinite values. That means we cannot assign individual probability for individual values of x. So therefore, what we will do is that we will not call it probability mass function, we will call it probability density function. And therefore, you can see that the rules will be here. Fx will always be greater than or equal to 0, and x can range from -infinity to +infinity. Please see each and every point. Binomial, what was the range? 0 से लेके n तक, finite number, वो भी positive integer. Poisson distribution क्या है? It starts from 0, but it goes up to infinity. But dear students, on the positive side, not on the negative side. मतलब एक रेंज है 0 और infinity, 0 या n. लेकिन in the case of normal distribution, it deals with certain variables which can assume values, negative values, fractional values, and infinite. So range is -infinity to +infinity. So the formal definition from the study material of ICAI, a continuous random variable x is said to follow normal distribution or Gaussian distribution. यहाँ पे दो पैरामीटर है, सो हमारे जो नए मित्र है, that is normal distribution, इनके दो पैरामीटर, very similar to binomial. Binomial we had two parameters n and p. Normal distribution also has two parameters. इसमें क्या है? mu and sigma, यानी mean और standard deviation, and both we know already. So you can see the probability, not mass function. क्या है ये? Density function. So the PDF probability density function is given by, थोड़ा सा complex, लेकिन याद रखना होगा धीरे धीरे. And I have full respect and confidence in all the students. They are super intelligent. They can do it. Minus, so you see the PDF 1 by sigma square root of √2 pi. So you have pi here, which is a constant, and now E, yani Euler's constant, e to the power minus x minus mu whole square by 2 sigma square. Please note two things, that here x can range from -infinity to +infinity. So this is called the normal distribution. Carl Gauss was the founder, the father of the distribution. So we will say he derived this distribution. So the normal distribution, out of respect to the founder, we call it Gaussian. And I also started thinking why it is called normal distribution. The binomial we know, NCX is actually, you may remember binomial theorem. A plus B is whole square, we know, A plus B whole cube, but A plus B to the power 10. So we know the coefficients will come through binomial theorem. So we know it is binomial. But normal distribution, Gaussian we know because Gauss was the founder. Now we see why normal, because the name was given, it's 200 years, almost the same time when Poisson and the Bernoulli experiments were held, and when Poisson discovered or invented, I'll say, when he invented this distribution. So you can see that scientists and mathematicians in those days, they were searching for a normal model which will describe the probability distribution of all continuous variable. So they were looking for a normal model which will, which is like one size fits all. That's why the term normal was introduced. So this time we do not have the probability mass function, we have the probability density function. I was referring a little while back to the fact that in case of PDF, probability density function, we are using the integration sign because here we have to find out the area under the curve. And in the chapter on integration, you have learned in the specific case of definite integral, integration of fx dx between the range lower limit a and lower limit b. Definite integral sochiye. So you can see the same is done here. And therefore, if you integrate, now you see exact mathematical concept. Integration of a function. Kya function hai? 1 by sigma square root of 2 pi into e to the power minus x minus mu whole square by 2 sigma square dx. So this is the function. We are integrating this probability density function between two limits, -infinity plus infinity, and the total should be equal to 1. This is the mathematical concept of the normal or the Gaussian distribution. Now we look at PMF versus PDF or एक बार, right? Now please see this primer which comes up on the slide. On the left-hand side, you can see a probability mass function that is a discrete variable, and the variable is occupying 6 values. You can see 1, 2, 3, 4, 5, 6. Probability is mapped 1/6. There are 6 possible values and it is random. So equal probability, so 1/6. So on the left-hand side, you can see I'm just turning my cursor. Accordingly, for the PMF, yani discrete variable, we can create the cumulative distribution function. Simple to understand. Why? Because the variable x is taking specific values from 1 to 6. Ekdam integer value, whole number. But now look at the right side, continuous. What is the problem here? You can see a graph, a curve. It is a bell-shaped curve. Why? Because here we are dealing with a continuous random variable which can occupy or assume any values within a given interval, and therefore we cannot use a probability mass function. We will call it a density function, and the cumulative distribution function will look like this, like a curve. On the left hand side you did not see a curve, on the right hand side you can see a curve. So now we look at one more example. Yeah, I thought why not link this with histogram. एक recap भी हो जाएगा. Chapter 13 काफी दिन पहले हम लोग डिस्कस किए थे. I don't know whether you still remember. So let us see a situation histogram. Let us create a relative frequency distribution बनाएंगे with the lower class limit is 31.5 and a class width of 1. Kuch typically this is what we will see. This is height of children. Okay, it's a continuous variable. Of course, positive. ये range जो है positive. It is always positive number, but it can be fraction. Now, the height of children randomly selected. If you try it out, even the heights of children or adults, whoever you take, here you can see a histogram, and heights of 2-year-old males are drawn, and we can see that the classes are all having a width of 1. Class width is 1 on the left hand side. You see a histogram, right? Please look at the diagram, the chart. बीच में सबसे ज्यादा frequency है. On the two extreme side, lower frequency. बीच में क्या है फिर? Highest frequency. That means mode is in the middle. We also know median is the middlemost value. By mode we have learned mode is frequency, highest frequency, modal class. So once, instead of this histogram, if I replace that, या फिर सोचिए हिस्टोग्राम को हम लोग ऐसे ही रखेंगे लेकिन एक कर्व ड्रॉ करेंगे which will connect the midpoints of all the upper, the breadth part of all the rectangles which you see. It will look like this, and therefore you can see it is nothing but a normal curve which we get. So once we join the histograms, yes, we can see it is a bell-shaped curve. Yes, so it becomes a bell-shaped curve. Please remember chapter 13 once again. See how we are applying the principles. So we had 4 types of curve: U-shaped curve, bell-shaped curve, J, and we had mixed curve. So this is a classic example of bell-shaped curve. And normal data, like continuous data, like heights, weights, exactly it will follow normal distribution. So we can see the practical side of normal distribution. We have looked at why the discrete probability distribution, we use the term probability mass function. And in case of the continuous distribution, why do we use the term probability density function? And why do we use integration? I hope you have followed and understood. Once again, now let us see our probability density function, fx. And now we will see there are 2 parameters you can see, mu and sigma. Once you know mu and sigma, you know the full distribution. Please see the graph now, the bell-shaped curve. So it is unique. Normal distribution is unique because what you get here is mean and median and mode. They are same. And now if you look at the 2 constants which are given, in the normal distribution, we are dealing with two parameters, mu and sigma. Mu is mean, sigma is standard deviation. Okay, fine. But there are also two constants. In the case of Poisson, we only had E, but in the case of normal distribution, we have both pi and E, which is the Euler's constant. E is the Euler's constant. So please see the values are given. And now we will look at the bell-shaped curve, a little more on that. It is symmetrical. Yani it is ekdam beech mein middle. If you draw smooth freehand curve, please note the two tails on the either side. जो आप देख सकते हो x-axis में जो दो tail है, it will never touch the x-axis. It will extend till infinity. Please remember this. Because normal distribution, we saw x can range from minus infinity to plus infinity. So when we draw the normal curve, the two branches, जो tail बनेगा, the taper ends, it will extend to infinity. It will never touch the x-axis. But bell-shaped curve hai, that means it is easy for us to note mean, median, and mode are equal. And random variable has infinite range. I hope you can follow minus infinity to plus infinity. And therefore, normal distribution क्या है? ये symmetric distribution कहलाता है. इसके दो parameters है, mu, which is mean, and sigma, जो है standard deviation. And x minus mu by sigma, which you see here. If mu is equal to 0, that is mean equal to 0, and standard deviation equal to 1, then we will get a distribution which is a simplified version of the normal distribution. We call it standard normal distribution. And ये जो phi देख रहे हो, the normal distribution on the, please see on the left hand side, the bottom left hand side of the slide, standard normal distribution is what? Most of the problems in the exam you will get in this particular form. So here the normal distribution, ऐसा एक normal distribution जिसके दो parameter mean 0 और standard deviation 1 होगा, उसको हम लोग क्या कहेंगे? We will give it a name, standard normal distribution, and the probability density function PDF will be shown as phi z. ये जो आप देख रहे हो, this z के आगे जो particular letter लिखा है, these are all Greek letters, alpha, beta, gamma, delta, pi, and this is called phi, phi, not pi. Pi is p, but this is phi. So we write it as phi z. And phi z, you can see, instead of x minus mu by sigma, we have written it, we have substituted that by z. So this is the standard normal distribution. And finally, before we go to the examples and the MTP RTP questions, quick recap of the PDF, yani probability density function. So continuous random variable, definitely for normal distribution, it deals with continuous random variables. Number two, it is biparametric. Please remember, binomial is also biparametric. It has n and p. Normal distribution is also biparametric. दो parameter है, mu और sigma. लेकिन Poisson distribution is uniparametric. एक ही parameter है, m. Mean भी m है, and variance is also m. Please remember. And therefore, we see here that once again, so that you do not forget, please see the probability density function x, y from minus infinity to plus infinity. Now I am sure it makes sense to you. And because of this reason, dear students, normal curve, once again I repeat, दोनों जो tail है दोनों side में, it never touches the x-axis. वो चलता ही जाएगा, it will never touch, technically, theoretically speaking. And now the last few properties for our exams, very important formula. So first and foremost, we can see for normal distribution, it is symmetric curve. That means इसका skewness is 0. Symmetric about mean. So, and mean, median, mode, all are equal in case of normal distribution. इसके दो inflection points है. Inflection point क्या होता है? Inflection point means the point at which the curve changes direction. Maybe in school you remember you studied about in the optics chapter. Mirror याद है? Concave mirror, convex mirror, plano concave mirror. मेरे को याद आ रहा है school days. Okay, so that means a concave, convex, these are curves, type of curves. So if you look at the top part of the normal curve, please see I'm moving the cursor. ऊपर का part जो है ये क्या है? जैसे हम लोग जब नाराज हो जाते हैं, we frown. If we frown, so our lips are like this, so like a bell-shaped curve. So ये जो frowning है, if you see, once the curve is coming down, now it becomes like a smiling face. So this. The change inflection point means the point at which the curve changes the direction. याद रखिए inflection point. Inflection point will always be mu plus sigma and mu minus sigma. यानी mean से one standard deviation to the left and to the right जो point मिलेगा वही point में curve का direction change हो रहा है. Very important principle. Also, now please see on the right hand side the other properties. You can also see on the left, just one point on the left side, number 6, as x increases without bound, the graph approaches but never equals to 0, जो मैं बता रहा था. As x decreases without bound, the graph approaches but never equals to 0. That means दोनों side में it goes on till infinity without touching the x-axis. Seventh important property. 68% of the area under the normal curve is within one standard deviation of the mean. Please, important, very important from our exam question point of view. Then we have about 95% of the area is within two standard mean. And finally, 99.7% is within three standard deviation. इसीलिए 6 sigma करके जो total quality management, process improvement, quality control system, you can quickly do a search, and there are many students who are now acquiring 6 Sigma certification, quality management certification. So it is a process control technique by which the company, whether manufacturing or service entity, will produce defect-free products and services. Why it is called 6 Sigma? Because the intention is that all the products which are manufactured, all the services which are rendered by the company will be of uniform quality, और ये सारे जो products होंगे ये एक normal curve का बीच का जो है mu यानी mean plus 3 standard deviation. बाएं तरफ 3, दाहिने तरफ 3. That means it will fall within the 6 standard deviation, 6 sigma. That means it will be of uniform nature. There will be no extreme values. And therefore, this is why it is called 6 Sigma. Last but not the least, we see when n, number of trials of a binomial distribution, is large, it can also become approximately equal to a normal distribution. Even Poisson distribution, uska limiting jo version, it will become normal. So binomial distribution first, given certain circumstances, can be approximated to a Poisson distribution. And in the ultimate phase, both binomial and Poisson as a limiting factor can be converted or can approach a normal distribution. For example, think of a Poisson. अगर Poisson distribution आप उसको आप graphically दिखाएंगे, it will have a positive skewness. बाएं तरफ the graph will be like, it will taper towards the right hand side. As the number of observation increases, यही graph जो skewness में था, positive skewness, वो धीरे धीरे flat हो जाएगा, and the curve will become close to the normal. It will become a bell-shaped curve. This is how the Poisson distribution can get transformed into a normal curve, normal distribution. 13th point, please note, very important. Skewness is 0. That means normal curve is neither inclined towards the right side nor towards the left side. But Poisson distribution thoda sa positive skewness hai, बाएं तरफ hai. And finally, the last 2-3 important formula, this you need to remember. Mean deviation of normal distribution is shown by 0.8 sigma. Quartile deviation की अगर बात करें, the first quartile, the lower quartile, is shown by mu minus 0.675 sigma. The upper quartile Q3 is given by mu plus 0.675 sigma. Yani, if I want to find out the quartile deviation, what is quartile deviation? Q3 minus Q1 by 2. It is the half of, it is known as the semi-interquartile range. So you will see it is equal to 0.675 sigma. Very important for our numerical problems. Inflection point, I've already explained the point at which the graph changes the direction. And you can see inflection point for a normal curve will be mean plus 1 standard deviation, mean minus standard deviation. So mu plus sigma, mu minus sigma, दो पॉइंट में बाएं का पॉइंट क्या होगा, mu minus sigma, दाहिने ओर का जो पॉइंट है that is mu plus sigma. So that is inflection point. Inflection point kya hai? I've explained once again. Let me see if it is written, if I've written it on the slide as well. Okay, so you can see inflection point is the exact point where the curve changes its curvature. And so we have seen mean deviation 0.8 sigma, quartile deviation 0.675 sigma. And therefore, we have talked about the fact that 99.7% of the area of a normal curve will be within 3 standard deviation. Now we move on to the last part, and then we will move to the questions and answers. So let us look at the application. Manufacturing companies are using normal distribution. We have seen the application of binomial and Poisson. So basically, for producing defect-free output, minimizing the errors, rejections, quality failures in a production line, very much practically used. We see the last practical example from the industry side. An FMCG company packages premium coffee powder into jar. Fine. Machine is calibrated, the packing machine is calibrated to a mean average weight of 250 grams. इसमें standard deviation हो सकता है maximum 2 grams. So mu we have known, we have got is 250, and standard deviation, yani SD, is 2. Right? I hope you are following this. Now it is given that the jar which has a weight under 246 grams are legally considered underweight. Please see the problem. Are legally considered underweight. Okay. Now we see that what percentage of production is rejected as underweight. It says mean is 250 grams. Standard deviation कितना है? 2 ग्राम है. अगर कोई जार 246 grams का, see Z is equal to nothing but x minus mu by sigma. Dear students, in earlier discussions regarding standard deviation, mean deviation, range, usse pehle when we handled the measures of central tendency, you may remember we were continuously discussing about two particular terms, whether if x and y are related, whether y is affected by a change of origin and by a change of scale. यहां पे आप देख सकते हो, we have used it practically. Z is equal to x minus mu by sigma. Here mu is nothing but the shift in the origin. Sigma is the scale factor. Right? So what we have done, this variate now becomes x is 246. We have to find out 246. X is 246. 246 minus 250 by 2. Mu is 250. Mean mu is 250. Sigma we have given, it is given 2. So therefore we get the Z score is minus 2. Minus 2 means in case of a study that Z is less than minus 2. Yani Z equal to minus 2 means 246 वाला जो line है, 246 grams को दिखाने के लिए the point उससे बाएं तरफ, that means it is less than 246, मतलब it cannot be sold. So we have to actually find the probability that Z is less than minus 2. It is given already, if you see in the last part of the problem, given area under the standard normal curve from Z equal to 0 and Z equal to 2 is given. Z equal to 0, 0 se plus 2 diya hai. We have to find out the area under the curve which is to the left side of Z equal to minus 2. Now we know it's a symmetric curve. I'm sure you understand symmetry. I also talked about skewness. We have discussed skewness through graphs, diagrams, I think at least 2 to 3 times in the earlier discussion I had on central tendency as well as on dispersion. Please refer to that. Again, I will show you for your reference, but please remember them because after 1 or 2 sessions, our classes will be over. You have to retain. आपको याद रखना पड़ेगा. Okay. So please note here, due to the fact that normal curve is symmetric, the area to the left of the point z equal to -2 will be actually equal to 0.5 minus the probability which is given. Because symmetrical hai. In the problem it is given the area between z equal to 0 and +2. Now z equal to 0 on the right hand side, +2, +3 jo bhi hai. So it is a symmetric curve. So we know that the area between z equal to 0 and 2 is given. We also know that the right hand part of the curve has a total probability which is half of the total probability. Total normal curve, we have seen that the area under the normal curve is 1. Yani ek, unity, 1. So half of the curve, uska kya area hoga? 0.5. 0.5 is the half of the curve. Usme the area between z equal to 0 and 2 is given by 0.4772. So the remaining part of the curve kya hai? It will be 0.5 minus 0.4772. That means it is coming to 0.0228. This is the probability. Yahi hai percentage, 2.28%. That means once we convert it to the percentage, what we are getting is the interpretation from the business world, from the production, from the operations is exactly 2.28% of the coffee jars produced by this company will fail the quality parameter, the weight requirement, and therefore will be rejected by the quality control department. See this once again, because we have to move on and already it's 4, so we have to take the questions and answers, important questions. You can see a detailed discussion on the chapter. It takes so much of time. So much of conceptual things are there. So many formula. It's definitely one of the more complex chapters. But our intention in the LVC is to convert a complex chapter into easy so that it becomes easiest for you to understand. Right? So later on, possible, pause, go through it once again, link it with the study material, do some of the problems, and then I'm sure in case you are still hazy on certain areas, you will get complete understanding. Now we go to the exam-oriented properties. मैं पहले बोला था, I will revise and repeat the key points again and again so that it comes into your mind. So once again, for the key exam-oriented properties, let us look at the core application, and then we will see the properties. Binomial application largely in risk management auditing. Variable element kya hai? It is fixed number of independent binary choices. Binary means 2 choices. Poisson, typically used in website traffic. We saw some problems, queue management, phone calls, quality control, when you talk about things like customer care. But we saw that it deals with rare probabilities. That means the probability is very less. And it has some time element per day, per hour, per week, per year. Normal distribution, most important part of the application is quality control. And it is dealing with continuous random variable, and therefore we use the term probability density function. Okay, clear? Next, exam-oriented property chart. Please see on the left-hand side of the slide. Once again, अभी तीनों जो है एक साथ एक ही टेबल में, binomial, Poisson, and normal. Just see whether each of these are correct. Variable type क्या है? Binomial and Poisson both are discrete, but normal deals with continuous. Please also note the fine difference in case of binomial. Discrete तो है, लेकिन the value starts x equal to 0, it goes till n, जो मैं बताया था, finite. But in case of Poisson, it can become very large, infinite. In case of normal distribution, x ranges from -infinity to +infinity, big, infinite values. That is why it is not possible to assign specific probability for specific values, क्योंकि infinite है. आप कितने probability assign करेंगे? हम लोग क्या करेंगे? We will now use integral calculus, so we use the term probability density function. पैरामीटर पे देखिए, गौर करिए, काफी क्वेश्चंस आएगा इसके ऊपर. In case of the binomial, it is biparametric, n and p. Poisson में क्या है? एक ही पैरामीटर m. m mean भी है, m क्या है? It is also the variance. Now we look at normal distribution. It is also biparametric. इसमें दो है, mu for mean, sigma square, जो कि है आपका variance. What is the key condition for binomial? It is for finite independent trials. For Poisson, rare events, which I mentioned. That means n is large, but p is very small. Normal distribution, it is symmetric bell-shaped. Symmetric bell-shaped. We have discussed about the point of inflection. We have discussed about the mean deviation, जो कि 0.8 sigma है. We have also talked about the quartile deviation, which is 0.675 sigma. And also the inflection point, which is mu plus sigma and mu minus sigma. Okay? Variance, तीनों का variance. For binomial distribution, variance is NPQ. That is, standard deviation now becomes square root of NPQ. Poisson, sigma square equal to M. Easiest to remember. Poisson is the easiest because uniparametric. Mean भी जो है भाई अपना variance is also same. Normal distribution again biparametric. Mean is mu and we have variance sigma square. Standard deviation I have shown. Now let us see some other coming up. Other factors. Mean versus variance, we have observed in case of binomial that NP is your mean and variance is NPQ, and we know Q is a fraction. Therefore, we can conclude that in case of binomial, mean will be always greater than variance. In case of Poisson, mean is equal to variance. You can see दोनों का value M है. In case of standard normal, that is normal distribution, no direct relation between mu and sigma square. Symmetry की बात करें, when you talk about the binomial distribution, discrete है, probability mass function कहलाते हैं. It is symmetric only when probability of success is equal to probability of failure. यानी P is equal to Q and both should be equal to half, that is 0.5. Now please see, मैंने skewness की बात किया है यहाँ पे. Normally the Poisson distribution is always positively skewed. Skewness थोड़े देर बाद हम लोग, again I will show you. I have deliberately added more number of photos and graphs. For every slide should give you idea so that you get, you learn from every slide. Then you have for normal, it is always perfectly symmetric. Normal curve का एकदम बिल्कुल साफ सुथरा, it's a bell-shaped curve which is symmetric, but the tail would extend to the infinity on the minus side, on the plus side. Central tendency in case of binomial, well, mean, median, mode will not be the same. In case of Poisson also, the mean, median and mode will not be the same, but in case of normal, for the continuous probability distribution, in case of normal curve, because it's symmetric, so mean, median, mode will be equal. Additive property we have seen, that means two distribution x and y, दोनों independent है, दोनों का parameter दिया है, फिर x और x plus y, what will be the parameter? So in all the cases, it will be identical. Only for binomial, अगर p same है, it will be holding good. Please see the next point on the left side, 6 sigma. So 6 sigma, now you understand. Now, any question which comes on 6 sigma, not just in the exam, but anyone asks you without using any tech tools or any GPT or any AI or any Google, you can give the right answer. That 6 sigma basically is derived from the concept of normal distribution and standard deviation. It is a goal for process improvement. And as we saw, it will result in, जो हम लोग देख रहे थे, that mean or plus 3 sigma or minus 3 sigma के अंदर क्या है? 99.9997% of the observations. That is why it is 6 sigma, और इसको हम लोग 3.4 defects per million opportunities कहते हैं. 6 sigma. And you can understand, jitna sigma level, higher the sigma level, lower will be the defect rate. That means more precision will come. And as a result, we know that sigma therefore refers to what? It refers that it would take a 6 standard deviation from the mean for an error to happen. यानी error होने का chance बहुत ही कम है, right? We now at last move on to set A questions. So it's almost 4:15. We now start with the questions. It will take some time because at least 30 questions we'll cover. Let's see. So probability distribution may be what? We are taking questions from set A. Probability distribution can be discrete or continuous. यानी option D, because discrete का example क्या है? We have binomial and Poisson, and for continuous we have normal. So please think once again as you answer. Question number 3, we have an important distribution. Okay. So some of the students have started answering. Please do it, but just silently do it because we have to go on, so many detailed examples, and that's what I try to do in every session. As many questions. First, we have the full in-depth study, para by para, principle by principle, each and every formula, all possible contours and colors of that particular topic. Then we have in-depth questions and solutions. So my target in every session is minimum 30 and above. In some of the sessions, thankfully, we could do almost 60 questions, specifically in the case of logical reasoning. Now we see the next question here. Important discrete probability distribution kya hai? Important discrete probability distribution, ye charon mein only Poisson. Normal nahi hai, Cauchy is not, and log normal is also not. It's outside our curriculum as well. Next question, number 7. A trial is what? A trial is first 3 observations. The first 3 options are not correct. You can see. Trial kya hai? Bernoulli's trial. We learned it in the the portion of the binomial portion of today's session. It is basically an attempt to produce an outcome. Or outcome kya hai? Neither it is certain nor it is impossible. Yani it will lie between 1 and 0. So please remember, this is what is called trial. Next question, if x is a binomial variable with parameters n and p, then x can assume what? X is a binomial distribution, discrete hai. It has 2 parameters n and p. So therefore we know the range is what? 0 to n. For Poisson, it will be 0 to infinity. For normal, it will be minus infinity to plus infinity. But for binomial, it is 0 to n. Please remember. 12th question, the mean of a binomial distribution with parameter n and p kya hai? So please note several questions in the ICAI study material in the exercises are from the theory part. I request all students once again, please practice theory questions as well. So please don't think that these are not important, only formula-based questions we will practice. No, kindly avoid that tendency. 12th question is NP, we have discussed. 14th question, an example of biparametric discrete. Poisson bhi discrete hai, lekin wo uniparametric hai. So therefore, 14th question, option A is the right answer. 18th question, the maximum value of the variance of a binomial distribution, even without looking at the options, we have discussed it multiple times today. When P is equal to 0.5 or half, when Q is equal to 0.5 or half, then NPQ, yani variance, will have the highest value, and it is equal to what? N into 0.5 into 0.5, which gives you N by 4. So the maxima, yani maximum value of the variance will be achieved when it is N by 4, yani 0.25 N. Option B, we will pick option B. Moving on, next to 29th question, the total area of the normal curve is what? Let's see the total area under the normal curve. Yes, 1, 50%, any value between 0 and 1. Yes, normal curve, 1. Total probability is 1. 30th question, the normal curve is what shaped? Well, it is a bell-shaped curve. The 31st question, the normal curve is what type of skew? Positive hai, negative hai, symmetrical? Ye hai symmetrical, yani iska skewness shunya. Skewness is 0. We will see skewness on this slide. Don't worry. There are some requests in the chat. I have seen that. We will see that. All answers are there for you. 34th question, mean and mode of a normal distribution. Yes, we have seen normal distribution is having a symmetric bell-shaped curve, which means mean, median, and mode will be same, identical. So 34th question, option C. Set B pe aayenge, number 19. If the mean deviation of a normal variable is 16, uska quartile deviation hai kya? Chaliye is pe kaam karte hain. So let us see. I have the pen and paper quickly. I have the solution, but let us work it out quickly. Mean deviation of a normal variable is 16. Mean deviation we know is equal to 0.8 sigma. So 0.8 sigma is equal to 16. Okay. So yahan se sigma nikalenge. 16 divided by 0.8. 0.8 means 4 by 5, 80%, yani 4 by 5. So 16 divided by 4 by 5, yani it will become 16 into 5 by 4. Chaliye 4, 16 cancel hoga. और सिग्मा अपना आता है 20 I am getting standard deviation 20. Question is, what is the quartile deviation? So sigma is equal to 20. We know quartile deviation QD is equal to 0.675 sigma, or we have already calculated sigma, which is 20. So what will be the quartile deviation? It will be 0.675 into 20. अब जो भी आएगा देखते हैं. 0.675 into 20 should be it will be 6.75 into 2, that is 13.5 I am getting. देखते हैं, अगर सही है तो अच्छा है, अगर नहीं है तो फिर से करेंगे प्रैक्टिस. So we see mean deviation is 0.8 sigma. Standard deviation therefore comes to 20, and quartile deviation we know is 0.675 sigma. So we get 13.5, option B. Next, chaliye, for everyone, probably last time, because next session will be correlation regression, we can't. Each of the chapters are huge, and if we really do justice, it is taking us on an average more than 2 hours, almost in all the sessions, because these are all very detailed, in depth, lot of principles, lot of formula, lot of concepts. So skewness, unless I know mentally what I will do, I will memorize. Memory एक दिन धोखा दे सकता है, but concept, you will never forget. Memorizing, it will sometimes you will not be able to recollect. So chaliye, now we see skewness क्या है. So all the students who have written about, requested me, please see, all answers are there. चलिए बाएं तरफ देखिए, positive skewness क्या है. बाएं तरफ you can see positive skewness means it is tapering towards the right hand side. गौर करिए, बाएं तरफ I am moving my cursor. Positive skewness means क्या, mode is coming first, इसके बाद मीडियन, उसके लास्ट में मीन है. दैट मीन्स इन केस ऑफ पॉजिटिव स्क्यूज, फॉर एग्जांपल पॉजिटिव स्क्यू का एग्जांपल क्या होगा, पॉइजन. यहां पे मीन विल बी मोर देन मीडियन एंड मीडियन विल बी मोर देन मोड. नाउ लेट अस लुक एट द एक्सट्रीम राइट साइड. आप देख सकते हो नेगेटिव स्क्यूनेस क्या है. यू कैन सी बीच में मीडियन होगा एज वी नो, लेकिन यहां पे बाएं तरफ मीन है, दाहिने तरफ मोड है, बिकॉज नाउ on the right hand side you can see this skewness. So it is like a mountain. बचपन में हम लोग ड्रॉ करते थे ना, माउंटेन सीनरी, याद है? माउंटेन ऊपर, sun rays. I don't know whether you have done it. We used to do it. Okay, so we used to draw mountains, and sometimes I remember I used to draw symmetrical. कभी इस तरह का skewness, तब पता ही नहीं था skewness क्या है, but बाद में I got to know. You can see these are like mountains which are tapering towards one side, यानी bias है, यानी asymmetric. It is not symmetric. It is a bit partial on one side. So you can see in case of negative skew, median तो बीच में आएगा, but here mean will be lower than median and median will be lower than mode. But in the case of the curve which you see in the middle, ये है bell-shaped curve. It is the normal curve. You can see this is symmetrical. That means skewness is 0, no skewness. So it is symmetrical distribution. I hope all students are clear on the skewness part. Inflection point, चलिए फिर से देखते हैं. Inflection point क्या है? Where the graph or the curve changes the direction. This is inflection point. Please see, friends. Please see inflection point. This is the central line. I'm just moving my cursor up and down. I hope it is visible. That means for a normal distribution, this is the mean, median, and mode. This is the point, sigma. So this is mu plus sigma, ye hai mu minus sigma. These are the 2 points you can see. I'm moving the cursor where the graph is actually, the curve is changing the direction. And you can also see in the same graph, आप देख सकते हो in this photograph, in this diagram, mu plus 1 sigma plus 2 sigma plus 3 sigma, यानी बाएं तरफ -3 और दाहिने तरफ +3, बाएं तरफ 3 sigma, दाहिने तरफ 3 sigma, टोटल क्या है 3 + 3 6, यानी 6 sigma के अंदर आप देख सकते हो 99.73% of the observations will fall. This is the intention of 6 sigma in the industry, that 99.73% of the products, of the services will fall within the range of -3 and +3 sigma. That is why it is called 6 sigma, right? So these are additional points. Now we move to next question, set B. This again, it is a repetition. You can see we have done it multiple times. Maximum greatest value of variance for a binomial, it comes to n by 4. Please remember, जो question repeat हो रहा है, यानी जिसका मोड सबसे ज्यादा है, फ्रीक्वेंसी ज्यादा है, एक्सरसाइज में भी है, एमटी में भी है, आरटीपी में आ रहा है. In the past year question is coming. So in our language, the language which we are now learning, the mode is maximum, yani frequency maximum. So these are more important. Please keep a note of it. Fifth question: what is the number of trials of a binomial having mean is 3 and SD is 1.5? Good question. Mean we know is NP. So NP is 3 and we have SD given 1.5. SD is 1.5. Yani variance kya hoga? Variance is 1.5 into 1.5. Yani square of standard deviation. So it is 1.5 into 1.5. Please write. But we know variance kya hai? NPQ. So NPQ is equal to 1.5 into 1.5. You are also given mean is 3. Mean kya hai? Mean is NP. So if I divide the value of variance divided by the value of mean, what do I get? Numerator में क्या होगा? NPQ. नीचे क्या होगा? Denominator में NP. क्योंकि ऊपर variance है, नीचे है mean. On the mathematics, on the number side, what will happen? Variance means 1.5 into 1.5. NP, that is mean, is 3. So numerator we have 1.5 into 1.5. Numerator, denominator we have 3. चलिए cancel करते हैं. NPQ divided by NP. So NP cancels. We are getting only the value of Q. बाएं तरफ equation का. दाहिने तरफ क्या रहेगा? 1.5 काटिए, it will go 2 times. So I am getting Q is equal to 0.75. Q is equal to 0.75, यानी 3/4, यानी probability of failure is 3/4. ये binomial है. So probability of success क्या होगा? यानी P क्या होगा? Q we have got 3/4. So probability of the P is 1 minus 3 by 4, that is 1 by 4. Clear? I hope you must be able to understand these steps right now. So P, if it is 1 by 4, now we know. Once again, see the value of mean. Mean is NP, which is given by 3. You have already got P equal to 1 by 4. So in this equation, NP equal to 3, I will substitute the value of P. And I will write N into 1 by 4 is 3. If N into 1 by 4 is 3, then N is equal to how much? 4 into 3, yani 12. Beautiful question. Kudos to the ICAI for giving us these lovely questions. Full, the entire solution is here. I've handwritten, you can understand. मैंने बैठ के ये handwritten, I've just typed it. As I solved it, I typed it. Next question, sixth question. What is the probability of getting 3 heads and if 6 unbiased coins are tossed simultaneously? Well, this is a direct application of binomial. You can just do it. You will get the right answer. Eighth question, what is the probability of making 3 correct guesses in 5 true-false answer type questions? Correct guesses. So either my guess is correct or not. So it's like a success failure. So direct application of binomial. So here, N, question number 8, set B. Here N, yani total number of trial is 5 and 3 correct guesses. So X is equal to 3. Probability of a guess is half. A correct guess, and the guess could also go wrong, it is half. So just putting the values, you can get the right answer. So it is 5C3 half to the power 3, because we want to know the probability of 3 correct guesses and therefore 2 wrong guesses. So दूसरा जो half है उसका if you see the indices, the number at the top, the power factor is 2. So we have 5C3 into half to the power 3 into half to the power 2. Set C, okay. If it is known that the probability of a missile hitting a target is 1/8, what is the probability that out of 10 missiles, at least 2 will hit the target? At least 2. So first and foremost, let us see the reasoning. So it is a case where 10 missiles are fired, yani it is a case of a finite number. So it looks like a binomial. It is a binomial distribution application. Here it is given the probability of a correct hit is P, which is 1 by 8. So I can find out the probability of a miss, yani target pe missile nahi lagega. Q, the probability is given by 1 minus 1 by 8, which is 7 by 8. The question here is, what is the probability that out of 10 missiles fired, at least 2 will hit the target? At least 2 means 2, 3, 4, 5 up to 10. We will find the complementary event. At least 2 means it is the complementary event of 0 and 1. That means from here, what we will do is we will first find the probability that not a single hit will be successful, and then we will find the probability of one successful hit. ये दो जो situation, that is x equal to 0, उसका probability क्या है, और x equal to 1, उसका probability क्या है. Once we add it, whatever value we get, इसका complementary event जो होगा, that probability will be the answer to this question, because at least 2 means the complementary event to this is either 0 and 1. So therefore, using this principle, putting the values, we have to find f0. That means the binomial function, the PMF, where x is equal to 0. And similarly, the PMF binomial where x is 1. So we do that and we get 30.3611. That means 36.11%. Eighth question, the important characteristics of Bernoulli's trials. Well, each trial will have two possible outcomes, success, failure, and the trials are independent. That also we know. So, yeah, option B, both A and B. Trials are infinite. Ye galat hai. Trials are infinite. No, for binomial Bernoulli, trials are finite. Okay, so C is not the right answer. We will go for D. Additional question bank. So we have done some of the selected questions, set A, set B, set C. AQB, additional question bank. When a coin is tossed 10 times, what do we use? Binomial, because this is a case of success failure, because coin can have either head or tail, two outcomes. Yani Bernoulli's trial ka first clause, yeah, first condition is achieved, is met, is satisfied. Also, in case of coin tossing, we know here the number of tossing is 10, finite number, so binomial. Question number 2, in binomial distribution, n means what? N means the number of trials. So this we have done multiple times. When P is 0.5, the binomial distribution is what? Please remember, when P is equal to 0.5, and therefore Q is also equal to 0.5. That means probability of success and probability of failure both are same. So it will be known as symmetrical binomial distribution. Numbers 11, if binomial distribution NP is 9 and NPQ is 2.25, easily you can find Q. We have done a similar problem little while back. We will do it again for this one, number 11. Mean NP is 9 and the variance NPQ is given as 2.25. So we write NPQ in the numerator. This is variance, please remember. And this is 2.25. Denominator, we will write NP, which is 9. So if I cancel out from the numerator denominator, I'm getting Q. Q is equal to 2.25 divided by 9. 2.25 divided by 9. Now, if I just calculate this way, we are getting NP is 9 given, mean, and the NPQ variance is given. So Q comes to how much? So just if you calculate, you will get NPQ is given 2.25. So from here, we can get the value of Q. Okay. Q is the probability of failure, of course. Okay. So we have the next for continuous events. Let us see, for continuous events, dash distribution is used. 21st question, continuous events, we have the normal distribution, which is why we use the probability density function. 26th question, we have binomial distribution is symmetrical when P is equal to Q. Okay. 49th question, in binomial distribution, parameters are, there are two parameters, we have N and P. Two parameters, we are having N and P. Okay. So we will now take the next one, that is 53rd. It is a binomial distribution given mean is 20, SD is 4. So just like question number 11, you can see we worked out the question number 11 also. And you may remember we got Q. Oh, after cancellation, I got Q equal to 2.25 by 9. 2.25 by 9 is actually 1 by 4. And 1 by 4 into 100 means 25%, yani 0.25. Similarly, in the 53rd question, let us work it out. Here it is given, I'll take a fresh page, okay. Here it is given, mean, yani NP is 20, SD is 4. SD is 4, गौर करिए, SD, be careful. SD, that is square root of NPQ. First, we will have to get the variance. SD4 means variance is 4 square, that is 16. And variance we know is equal to NPQ for binomial. Question is, N ka value kya hai? So what we do is the same principle. We will first write NPQ in the numerator. In the denominator, we write NP. And NPQ value, we got 16. So I put 16 on the numerator, right hand side. In the denominator, we have NP, that is 20. So now from the left hand side, you can cancel NP. You are getting Q. Right hand side, if I eliminate, I get 4 by 5. Q comes to 4 by 5, yani 4/5, yani 0.8. Okay. So it's a binomial. So P ka value will be 1 minus 4 by 5. That is 1 by 5. So P you have got 1 by 5. You also know that mean is 20. Mean kya hai? Mean means NP. NP is 20. And now you have got P equal to 1 by 5. So I will put the value of P in the equation NP equal to 20. यानी मेरे को क्या मिलेगा? N into 1 by 5 is equal to 20. So N should be equal to 100. I am not very sure. Let's see. चलिए, option सही है. B option पे ताला लगाएंगे. It is 100. So this is how we achieve the correct answer. The 73rd question, the mean of a binomial distribution is 5 and standard deviation is 3. These type of questions, I will request all my dear students here to please practice enough number of questions from this type of pattern. Mean of a binomial is 5 and standard deviation is 3. So is it true? Very beautiful question, intelligent question. Mean is NP, we know. And standard deviation is 3. Okay, standard deviation is 3 means NPQ. Variance is 9. Okay, so we know that mean is NP and we also are getting, and mean is how much? 5. NPQ is 9. But there is a problem because NPQ is what? NP into Q. अब Q क्या है? Probability है. उसका value हमेशा fraction होगा. It will always be a fraction. It will be less than 1. So therefore, how can I multiply a fraction which is less than 1 with 5? And how can I get a value of 9? I will always get a value less than 5 because I am multiplying 5 with what? With a fraction. Hope you have understood it, dear students. Right? So therefore, you see this given statement is wrong. It is false. Let's see the options. True, false, both. Okay, so false. We proceed to 74th question, the expected value of a constant K. Expected value of a constant K will be the constant itself. Okay, no doubt about it. 76th question from the AQB. We are on slide number 20. Okay, right. Theoretical distribution is what? Theoretical distribution is not a standard distribution. It is not a random. It is an example of probability distribution. And for our curriculum, we have 3 types, 2 from the discrete, 1 from the continuous pattern. 76 ke baad, let's see, we have 88th question. In continuous probability distribution, probability that X is less than equal to T means what? Please mentally think of the normal curve. Mental mapping, quickly. Your mind should be like a supercomputer. Quickly. Think of the normal curve. There's a point on the x-axis which is T. And we have to find the probability that X, yani the random variable, has a value less than equal to T. So how do we find it out from the normal curve? By finding the area in the normal curve to the left of the vertical line at T. तो नॉर्मल कर्व ड्रॉ करिए, एक्स एक्सिस पे एक पॉइंट लगाइए टी, टी से एक वर्टिकल लाइन पूरा नॉर्मल कर्व तक ले जाइए. इट शुड टच द flow, the curve. It will intersect the curve and look at the area on the left hand side. Similar things you have done in the chapter on integral calculus, especially for definite integrals, right? I hope you follow and you understand 88th question. Now some additional 21. Which one is an ununiparametric? Okay, we have discussed this through comparative charts. Poisson is the only example of uniparametric as per our curriculum. 22nd question, for a Poisson distribution, which one is correct? Poisson, we know it is uniparametric. It has one parameter P. We also know that, it has a parameter M, which stands for mean as well as variance. And therefore, for the Poisson distribution, mean and variance are equal. Both are denoted by the letter M. 23rd question, Poisson distribution may be what? It could be bimodal as well. Okay. Next, we have what is the value of skewness for a standard normal distribution. We have discussed this: greater than 0, less than 0, or it is 0. So we have seen for the normal distribution, it is basically a symmetric curve which does not have any type of bias towards the left side nor any bias towards the right hand side. Therefore, we would say that option C is the right answer. Here, skewness is 0. However, please remember, once again, for your quick reference and understanding, Poisson will have a slightly positive skew. That means it will have a skewness greater than 0. 25th question, if the probability that a standard normal variate lies between 0 and 1.5 is 0.4332, what is the probability that Z is greater than 1.5? Okay, think of the normal curve. Normal curve, there is a point, 0 is the beach, ekdam beach mein, because mu is 0. This is a standard normal distribution. Mu, mean is 0. Standard deviation is 1. Probability they are asking is the probability that x is greater than 1.5. Okay, so we know that 0 to 1.5 the area is given, that is 0.4332. 0 से यानी दाहिने तरफ कर्व का बीच से दाहिने तरफ 0 to 1.5 you know the area. You also know that the total area on the right hand side is 0.5 यानी half. Why? Because normal curve जो है a symmetrical curve है, the total area in a normal curve is 1. So 0 से दाहिने ओर यानी 0 to plus infinity. If you think from that angle, the total area has to be half, 0.5. And we know 0 to 1.5 is 0.4332. So 1.5 ki दाहिने ओर, what is the probability that x is greater than 1.5? That means the area of the normal curve on the right hand side of the point z equal to 1.5. So this answer would be 0.5 minus 0.4332. If you work it out, reasoning, फिर से देख लीजिए, total area to the right of the mean, we know normal curve is symmetric. बीच में you have mean. Right side की हम लोग बात कर रहे हैं, यानी positive side, x axis, positive side. So the total area is 0.5. It is given in the problem that the area between the point 0, z equal to 0 and z equal to 1.5 is 0.4332. Total area 0.5 और 0 से 1.5 का बीच का एरिया क्या है? 0.4332. So 1.5 के दाहिने ओर का जो एरिया, रिमेनिंग एरिया क्या होगा? We just subtract. And therefore we are getting 0.0668, yani we will click option C. This is 25th question. 26th, if x is a normal variable with mean is 50, standard deviation is 10, what are the points of inflection? Inflection कितने points होगा? 2 points होंगे in a normal curve. Inflection point क्या है? Once again, for recap, the point where the normal curve is changing direction, concave to convex and vice versa. ये कहाँ होता है? The standard 2 points of inflection will be mu plus sigma and mu क्या होगा? Minus sigma. Correct. So here it is given mean यानी mu is 50, standard deviation है कितना 10. तो फिर कौन सा पॉइंट पे होगा? म्यू प्लस 10 करिए और म्यू माइनस 10 करिए. म्यू प्लस 10 करने से 50 प्लस 10. सो आई एम गेटिंग on the right hand side, I'm getting the point 60, and inflection point on the left hand side, I'm getting 50 minus 10, so 40. So the 2 points as per my understanding is inflection points in this case. Question number 26 is 40 and 60. Now let us see the options. Okay, I hope you can see option B appears to be the right answer as per our reasoning. Okay. We finally move to the MTP and the RTP questions now, and we start with the first one. Number of misprints per page of a thick book. Remember, we discussed any type of question which talks about number of observations per unit time, या फिर per geographical area, या फिर per book, per class, okay, or per batch of materials, usually pause off. So we will click option B. MTP question number 2, if for a poisson variable f2 is equal to 3f4, beautiful question and intelligent question also. What is the variance of x? So without we'll work it out. Let's see. I request all of you to work it out, and just listening to the reasoning, I hope you can do it. Poisson variable क्या है? So Poisson will write e to the power minus m into m to the power x by x factorial. ये है probability mass function. F2 is equal to 3f4. F2 means what? F2 means the probability that x is equal to 2. So ये जो probability mass function है उसमें x की जगह में we will write 2. So what am I getting? E to the power minus m to the power 2 divided by 2 factorial. See if you have written that. This is equal to what? 3 into f4. 3 into f4 means what? 3 times f4. f4 क्या है? f4 means the probability that x equal to 4. So if x is equal to 4, what will the probability mass function look like? I write it once again. When x equal to 4, it will be e to the power minus m into m to the power 4 divided by 4 factorial. Right? Now we equate them. It is given f2 equal to 3f4. So on the left hand side, I have got f2. क्या है वो? E to the power minus m into m square by 2 factorial. Right side, I am writing 3 into e to the power minus m into m to the power 4 divided by क्या है? 4 factorial. If you are doing it with me, look at the equation, and now we can cancel some values, some figures. E to the power minus m cancelling, m square cancelling from the left side. So दाहिने तरफ I'll get m square now. नीचे 4 factorial जो है right side का जो denominator है 4 factorial, I can write as 4 into 3 into 2. So 3 and 3 is cancelled. Either 2 and 2 is cancelled. I am getting बाएं तरफ कुछ नहीं, it is 1 now, and दाहिने तरफ I am left with m square by 4. So I am getting m square by 4 equal to 1. So m square, I am getting what is the variance of x. So let's just check m to the power 4. So what I am getting is variance of x. M square is 4. M square is 4. So m should be equal to square root of 4. So m is 2. Now we know for a Poisson distribution, the mean is m and the variance is m. So for question number 2, I will click option A, which is variance coming to 2. A beautiful, very intelligent question. Question 3, if the 2 quartiles of a normal distribution are 47.3 and 52.7, what is the mode of the distribution? Another superb question from the ICAI MTP RTP, right? So here we have 2 quartiles. You know that the 2 quartiles in case of normal distribution are given by mu plus 0.675 sigma and mu minus 0.675 sigma. You are given these 2 values. So first what we'll do, we will just, once you add it up, you will be getting the first and third quartiles. You can see mu minus 0.675s and mu plus 0.675s. So two equations you can see on the slide. First is for 47.3 and the next is for 52.7. Please see whether you are clear step by step. So from these two equations, what shall we do? We will eliminate one of the variable. So once we add these two equations, we are ultimately getting rid of S, yani sigma. So we are now getting 2m is equal to 100. 2m is 100, so m comes to 50, yani mean is now 50. Okay, mean comes to 50. Okay. If mean is 50, question is what is the mode of the distribution? Also find the mean deviation about median. In case of the normal distribution, we know mean, median, mode are same. So therefore, if mean is 50, well, mode is also 50. Question is what is the mode of the distribution? So mode is also 50. Now we come to the last part. Find the mean deviation about median. Well, we have also been able to get another formula, another result from here. Well, if mean is 50, then we can also from the equation one, please see, m minus 0.675s, we can easily find out the value of standard deviation. We will put the value of m here. We can get the value of standard deviation. Standard deviation s comes to 4. Now, since in case of a normal distribution, mean is equal to median, that is also equal to mode, please note, therefore, the mean deviation about mean will also be equal to mean deviation about median, and it will also be equal to mean deviation about mode. We know mean deviation is 0.8 sigma. So here we can see 0.8 sigma in this case is sigma kitna hai? Sigma is S, it is 4. 0.8 into 4 is 3.2. So therefore the answer is 3.2. Very intelligent and a wonderful question. Request you all to practice more questions like these. Fourth question, the total area of the normal curve. This is an easy one. So we know it is 1. Total area under the curve is 1. We have handled numerous questions on this statement. Fifth question, the mean and mode of the normal distribution. Well, mean, median, mode of a normal distribution will be equal always because the normal distribution is a symmetric bell-shaped curve, right? So please see that also I'm trying to explain the reason so that you are absolutely convinced, and that will give you the confidence that yes, I have understood. I am not using any guesswork, nor am I using hit or miss, trial and error. I know, and therefore I am opting for the right answer. That confidence we require. Last lot of questions. Number 6. An experiment succeeds thrice as after it fails if the experiment is repeated 5 times. So the probability of success is 3 times the probability of failure. Another, I would say, very challenging question also, and maybe a stimulating question. So the probability of the success, it succeeds thrice as compared to its failure. That means if the probability of failure is Q, P will be 3 into Q. So we can write P equal to 3Q, but we also know Q is equal to 1 minus P. So we can write P is equal to 3 into 1 minus P. From there, we are getting the value of P, which is 3 by 4. If P is 3 by 4, and we are talking about a binomial distribution, so therefore Q will be 1 minus P. P value is 3/4, so Q has to be kitna? 1 by 4, right? Question is, what is the probability of having no success if the experiment is repeated 5 times? So now think of the Bernoulli's trial, think of binomial distribution. Here n is given, n kitna hai? 5. Probability of having no success, yani x is equal to 0. So in the calculation part, we are now getting, when n is 5 and p is 3 by 4, and we have found q is 1 by 4, so we put that here. So the probability mass function becomes NCX P to the power X Q to the power N minus X. That is the probability mass function of binomial, as you know. And in this case, therefore, probability of no success, matlab kya hai? Probability that X is 0, yani F0. Function of X, when X is 0, we will write as F0. F0 क्या होगा? X की जगह में हम लोग 0 डालेंगे. So ये जो probability mass function मैंने लिखा NCX P to the power X Q to the power N minus X, there we write X equal to 0. So I am getting, and N is 5. So 5C0 P to the power, P का क्या amount, the value is 3 by 4. So 3 by 4 to the power 0, and then Q. Q is 1 by 4. Q का power क्या है? N minus X. Here N is 5, X is 0. So 1 by 4, उसका power होगा 5. 5 minus 0, यानी 5. The answer works out to 1 divided by 1024. Okay, good question, please. Seventh question, X follows normal distribution with mean 50 and variance 100. What is the probability that X is greater than or equal to 60? This is based on the standard normal variate principle. Mean is given. So we know standard normal variate कैसे हम लोग लिखते हैं? Z is equal to X minus mu by sigma. Here X is how much? X is 60. It is given. X is greater than or equal to 60. So the point is X equal to 60. So the variate, standard normal variate Z becomes 60 minus mu by sigma. Mu कितना है? Mu is mean. Mean is 50. So I write 60 minus 50 divided by sigma. Sigma क्या है? निकालिए. Variance 100 है. So sigma, standard deviation, क्या होगा? Square root of 100. So we will find the square root of 100 is 10. So finally, I am getting the standard normal variate Z is equal to X minus mu by sigma. That means 60 minus 50 by 10. How much does it come to? 60 minus 50 is 10. 10 divided by 10. So it's 1. That means Z equal to 1. Great. It is given phi 1 is 0.8413. So you know phi 1 is 0.8413. That means we have to find out now what is the value, the probability that Z is more than 1. X more than 60 means, more than or equal to 60 means Z should be more than or equal to 1. That means we know the total जो अपना normal curve का जो total area है. So let us now break it down. I hope you have got the answer, but this is the last question with which we are closing. It is almost 5 now. And we see the last final example. So this is a classic case where we have found out the value of Z, and you can see, as I was saying, create the value of Z, X minus mu by sigma, that is X is 60, 60 minus mu is 50, 60 minus 50 by 10, क्योंकि variance 100 है, so standard deviation कितना है? Square root of 100, that is 10. Target value क्या है आपका? The target value X is 60, वो निकालना है. And therefore I create that. You can see substitute करने से you are getting Z equal to 1. And we are already given phi 1 is 0.8413. Yani what we need to find out is the area on the right hand side of the normal curve at the point Z equal to 1. Friends and dear students, please see the last part of the slide. The normal graph, the curve is given. The shaded area which you can see here is basically the area, the yellow color which you can see is here. X is 60. You can see I'm moving the cursor. I've given a red line here. The mean is in the ekdam center, beach mein. We know mean, median, mode is same for normal. It is shown by the green dotted line which indicates mu is 50, and you can see the shaded yellow color which is the area of the normal curve to the right side of the point X equal to 60. In other words, Z equal to 1. This is the lovely nature of statistics. This is called the shift in origin and scale. So X60, we have shifted the origin and we have shifted the scale. So we have put it 60 minus mu by sigma. We have got Z equal to 1. So I hope you can understand, for the normal distribution, x equal to 60, it is now converted to another normal distribution, which is called the standard normal distribution. And we have done it by shifting the origin and the scale. And in this way, you get the answer. The total area we know is 1, and therefore the area till यानी बाएं तरफ से यहां तक एकदम बाएं ओर से माने from the left infinity side to x equal to 60, the area is given. It's a beautiful question from the study from the ICAI MTP RTP. You can see, so the right hand side, the shaded part is what? Total area minus the given area. Total area is 1, given area is 0.84. So if you subtract, you are getting approximately 0.1587. It can be rounded off as 0.16. In the given question in the RTP, the nearest option I am getting is option C. I request all dear students to go through the types of probability distribution, industry business applications. This you must know for your interest. Random variable B, please be very clear about both discrete and continuous random variable. We discussed in detail why it is called probability mass function for the discrete distribution, and for the continuous distribution, we replace the word mass with the word density. Please be clear with that. If necessary, look at the part of the video where I discussed on that. Next, please be clear about the features of binomial. It is biparametric. But please remember, Poisson is uniparametric. Again, normal distribution is biparametric. Solved examples, फिर से देखिए, फिर से analyze करिए, and be clear about the important features of normal distribution. We also talked about the skewness. Please remember, Poisson, the skewness is positive. So skewness is actually more than 0. On the other hand, normal distribution skewness is 0. Why? Because normal is perfectly symmetric, right? I hope every point I'm saying comes back to your mind. Industry applications, we discussed about 6 sigma. Number of solved examples. Finally, we concluded with exercise set A, set B, additional question bank, and MTP RTP. Exam tips, I will only say, please go through the principles now that we are coming almost to the end of our long journey of LVC in QA. Focus on time management, focus on accuracy, focus on once again revising the concepts. And before closing and completing the session, requesting you to once again look at the last time the main features of the 3 friends we have got to meet today, that is Mr. Binomial, Miss Poisson, and say again Miss Norman. So 2 girls, 2 ladies, 1 gentleman. So let's see the features. Please remember, binomial is discrete, Poisson is discrete, non-EF, probability density function. Binomial, remember please, 2 parameters, n and p. Once you know n and p, you hence m. Even if you know the rate, which is shown sometimes by lambda, rate per hour, rate per day, you can find out mean. Normal distribution, please see, last column, 2 parameters, mu and sigma square. Looking at the formula, please remember the formula. Binomial, NCX, p to the power x, q to the power n minus x. Don't look at the slide. Repeat with me. For the Poisson, e to the power minus m into m to the power x divided by x factorial. And for the normal, this normal is sometimes difficult to remember, but I know CA full form means, can achieve. So CA students also have that burning desire. Okay, so fx, you can see for the normal 1 by sigma square root of 2 pi, and then you have e to the power minus x minus mu square by 2 sigma square. Finally, the range of x, please remember, for binomial, it is finite, 0 to n, but only positive. No fractions, only integers, positive integers. Poisson, it will go up to sigma. Sir mentioned in the very beginning, for Poisson, it is a rare occurrence and the number of trials are infinite. So it will go till infinity. For normal, please remember, x will range, yani variable will range from minus infinity to plus infinity. That is why in the normal curve, the 2 tail of the curve will never meet the x-axis. They will go on and on like 2 tracks, railway line. They are always so close, but they will never meet. Okay, and finally you have the parameters. Mean, please be clear, mu is NP for binomial. For Poisson, mu is equal to m. and normal, you know, it is mu. Variance, please remember, for binomial, it is sigma square given by NPQ. So standard deviation becomes square root of NPQ. For Poisson, sigma square is m. Yani, in this case, the mean and the variance are same. For normal distribution, we have seen it is sigma square. And therefore, the standard deviation is given. Please, before we close, please remember also the additional formula, that is for the mean deviation, which is 0.8 sigma, for the quartile deviation, which is 0.675 sigma, and last but not the least, the point of inflection, that is mu plus sigma and mu minus sigma. So with that, we have Sir with us. So thanks a lot, sir, for again continuous your support. So
And good
yes,
evening, sir. Once again,
good evening, sir.
very nice lecture, and you have concluded with a good number of examples, and the last slide, which is very useful for the student. And before this thank you slide, that's what I want to say. And
Thank you, sir.
thank you once again. And
Thank you, sir.
it was a very nice lecture, and students must be enjoyed today's section, and in terms of gaining knowledge, and it will be definitely helpful for them in terms of examination for clearing the CA foundation course. Thank you once again.
Thank you, sir.
CA RJ Chakravarti, sir.
Thank you.
Welcome. Thanks. Thank you, students.
Thank you, students. We can, I request our tech support team, sir, to kindly conclude the session. We meet next day for the next session on correlation regression. Till then, keep practicing. Take care. Bye. Thank you.